Did we lose connection or?
I guess.
Yeah, the glitch.
Like
for a second or two.
someone has claimed my host role and muted him. I don't know how or why.
Yeah.
Yeah, I got that.
We are okay? Yeah, all right.
Yeah, we are okay.
Okay.
Hello, Gautam.
Yeah, is it? Can you hear me now?
Yes,
Yeah.
we lost you for a few seconds. Yeah.
Okay,
Yes.
okay. Shall I continue, right?
There was a glitch on the WebEx.
Oh, okay. No problem. I'll continue.
Yes. So WebEx also should have over voltage protection and lower voltage protection. Then only we can survive.
Yeah. Right. So if we look at the state of charge, so in this 0 to 3 seconds, what happens is, since the power is high from the solar panels, the state of charge is increasing of the battery. Then what happens is, it remains constant since there's no load at this point. There's no power requirement at this point because there's no, the ED system is disabled at that point. So then the state of charge remains constant. Then what happens is, the irradiance is less and the power requirement is more in this 4 to 6 seconds. So then the state of charge decreases. So this is for a small time period. We have just zoomed up the time scale. If you see over here, it is like for over 1 year, but this we have zoomed it down to like 8 seconds to see what happens like at a small time scale. So this is basically how the battery and the load currents look. So it has to be optimized still. The converter design has to be done such that there's no glitches or there's no the PI controllers, etc., which are present in the system. Those which are present here, those have to be optimized in a better way. So there will be digital control algorithms which will be used.
1 minute to conclude. 1 minute.
Yeah, so it's over almost. So basically what we have done in this paper is to model the ED system and develop the control strategy and the power electronics for the to take care of the demand basically. And then this ED system can be a very good, if it is PV powered, it has great potential to provide water directly to the people in rural villages because it is cheaper also. The ED systems are much cheaper than the RO systems. The rate of recovery is higher and even the energy efficiency is higher. So this work has been to validate or to try to see how we could develop a solar powered, a standalone kind of system to have clean water supply for rural India. So I think if the time is up, I can.
Yeah.
Okay. Thank you then.
Okay. Thank you, Gautam. Just one
yes.
Just quick questions or comments. What is your plan to calibrate this model versus a real system, right? Because that has to be validated. The second thing is the different types of simulation which you'll probably need to do, right? Based on sun coming, going, and all that, right? And there's load on the system demanding water. And the third one is there a dependency on the quality of the water input? How does that change your model, if at all? Is there any correlation in any way?
Okay. So the first part was how are we going to calibrate the model? So already the model has been validated. Like there's an experimental setup at Warwick. So they have already validated the model with the experiment. So if you can see here, the simulated versus experimental performance for the different conditions have been almost they are similar. So by calibrate, what do you try to like? What are we trying to understand from that? Like
because you're going to finally build a physical system, right? And your model, how closely does it follow the actual physical system based on different components that you get? right? So
Okay. For an Indian scenario, that's a rural scenario you are trying to say? Okay.
So, and that's a longer question for you to answer, but just something for you to think about. And if this depends on, for example, the quality of water that comes into the system. How does that ED system actually work? Is there some additional model input that you need to give in based on the inflow and outflow?
Okay. Yeah.
Right, because your outflow could potentially be different, right, depending on stuff like that. So, Dr. Das, do you have any questions or anybody else? Ashok?
I guess no questions from anyone. So can we move forward?
Yeah, please go ahead. Thank you, Gautam. This is very interesting. Thank you very much.
Thank you, sir. It's a good opportunity to speak on in this B-HTC conference. Thank you.
So, thank you.
Going forward, we have a credit user of 5. Hamjad Ali Mutana, can you hear us?
Hello?
Can you please try something?
Yes, sir. Is it audible?
Yeah, you are audible. Can you be a screen?
Yes, sir. I'll share the screen, sir. Is it visible, sir?
Can you make it full screen? Yeah, done. Please start.
Good morning, sir. Hello?
Yeah, please start.
Go ahead.
Sir, I am Professor Vijayapur, working as assistant professor in BLDEA'S V.P.Dr.P.G.Halakatti and Engineering Department. Firstly, I would like to thank my good team, BSPC 2020. And
I'm sorry to interrupt, Professor Amjad. Your audio is a little weak. Is it just for me or Advait? Are you able to hear clearly?
No, sir.
Sir, now can you hear me?
Yeah, now it's better. Can you get closer to the mic?
If you can come closer to the mic or
Microphone.
Sir, hello. Good morning. Sir, good morning. I am Hamjad Ali, working as assistant professor in technical department and BLDEA'S Vijayapur. Firstly, I would like to thank the BSPC 2020 whole team and BLDEA'S management for providing me the opportunity to present my paper. So, my paper title here is Implementation of Automated Water Supply and Distribution using PLC and SCADA under the track Humanitarian Sanitation. So, now the next presentation will be continued by my student called Internal Building. Hello? Hello? Good morning, sir.
Yeah, we are here. Yes, please go ahead.
Good morning, sir. Myself, Mishra. I am studying Electrical Engineering in Vijayapur. So, today I would like to present my paper that is Implementation of Automated Water Supply and Distribution.
Mutana, the audio quality is very choppy. Advait and others, can you hear him clearly? Or
No, sir, it's very feeble. Actually.
it's the quality is very choppy, coming in and out, very weak.
Yes, sir. I will change it. Sir, now. Hello, now, sir.
Yeah, now it's better.
Sir. So, my paper is Implementation of Automated Water Supply and Distribution using PLC and SCADA. So, the first part of this paper is Hamjad Ali Mutana. So, let's begin.
Your audio is breaking.
Yeah, the audio, I'm barely able to make out anything.
Wait a minute.
Should we check with the next one and come back to them later?
No.
Yeah, I think so. If Professor Amjad and Mutana, if you could just sort out your audio thing, and then we will come back to you.
Okay, sir. Fine. Thank you.
Okay, because we are barely able to make out anything. Yeah, Advait, I think you should go to the next one and then come back to them.
Yes, sir. I have made paper ID 246 as presented.
Okay, thank you.
My voice audible?
Yes, it's audible.
Yes. Just give me 1 second. I will open the presentation myself. Yeah. Is my screen visible, sir? Okay. So I'll just directly get to the presentation. Good morning, everyone. My name is Dwandil, and I'm currently in my second year of PhD. Sorry? Okay.
Yeah. Go ahead,
Dwandil. Continue on this.
Yeah, please go ahead.
Right, sir. Sure.
Yeah, go ahead, please.
Just 1 second, sir. Apparently, there was some connection issues on my end.
Oh, okay. You can turn off your video in case they are having bandwidth issues. That's not an issue problem.
No, sir. It is working fine now.
Okay.
Yeah, so I'll just start. Good morning, everyone. Myself, Dwandil. I'm actually doing my PhD in collaboration with Space Application Center, ISRO in Ahmedabad. And what I'm looking at is the modeling of long-wave radiation throughout different agroclimatic zones over India, and how they can be affecting or altering the water and the evapotranspiration, which influences the agricultural parameters, and how they can be modeled so that it can be used in a better manner. So long-wave radiation actually comes under a huge branch known as ECV, or Essential Climate Variables. It was coined in 2014 by IPCC, which is talking about the adaptation and providing statistical and empirical evidence to use and understand and model the Earth's climate. So currently there are roughly 56 variables which are being considered under this branch, the latest one being lightning, which was introduced last year. Long wave radiation or net radiation balance itself is one of the key parameters at the surface. So it can be expressed in the standard budget equation, where you have the amount of radiation coming in and whatever is being retained, the remaining being blown away or being reflected or emitted back. Incoming long wave radiation is actually one of the key components in the surface radiation budget, which is measured in the range of 4 to 100 micrometers, influencing by so many gases, like you have the water vapor, the columnar precipitable water, the carbon dioxide, and methane, and other remaining trace gases, especially ozone. So while it is being influenced by these trace gases, it is also being influenced by the air temperature and whatever is available on the surrounding near the surface. Now the problem is that because of climate change, there is an apparent variation within the Earth's surface and the atmosphere itself, especially in the lower atmosphere. One, it could be due to the net increase in the solar radiation which is entering if the ozone is getting thinner. Second, there is a change in the fraction of the radiation being altered. So if you are under clear sky like in summer, it's unbearably hot. But if you look at the weather today, while there are certain clouds available, you still feel unbearably hot, at least in the afternoon when you're sweating like anything, irrespective of your location. And the third reason could be the change in the concentration of these gases, which is actually causing one of the key factors in climate change. All three of them can be defined in the terms of radiative forcing. Now, radiative forcing is actually a physical driver of climate change itself, where you have multiple trace gases and the aerosol part, or you have the cloud particles, or you have the ice particles, or the whatever carbon that we emit, not to mention the key influence by human, like fossil fuel burning or forest fires that are happening in California or other places. All these things drive into influencing the radiation budget in different locations. While we talk about fog, when you branch out the entire atmosphere of the Indian subcontinent in 4 branches, one who has completely cloudless, which is crystal clear. The second one comes to cloud, which happens majorly during the monsoon season. The third one happens predominantly in the northern part, which is fog. So from going to the Indo-Gangetic Valley, from Delhi to going all the way to Bengal, that time a lot of things are not visible and the visibility is even less than 1 kilometer for us. So the cloud which forms on the ground, which reduces these visibilities by less than 1 kilometer or even 2/3 of a mile, that component itself is known as fog. So there are actually 4 different variations in it. One is the radiation, which happens because of these temperature variations. I'll come to that further on. The advection, upslope, and steam fogs are different parts which happen throughout the world in different situations, like if you have some flowing from a valley to up because of their mountainous barriers in the middle, or if you have something which is induced by humans in different manners. So if you look at it, this particular image was taken from the INSAT satellite in 2015. All the white portion that you see on north of India here is completely covered by fog. Now, this much fog over the Indian subcontinent, one of the biggest challenges here is that a lot of satellite measurements are not possible under these conditions. So the radiation measurements like the insolation or other surface temperature, air temperature while it is being modeled, the other two are being blocked away and there are literally null values available. So problem is that if we are planning to model it and use it for crop irrigation by estimating DT, it's not physically viable because we don't have measurements of that region. So how does it work? So these fog regions normally happen during valley bottoms, which we have in the northern part just before the Himalayas start. It typically dissipates or burns shortly after sunrise, but it also depends when the inversion is going away. So if the conditions are clear, crystal calm, then the temperature cools down to the dew point where it becomes to form cloud condensation in the ice, and these particles make it so thick that we can't see beyond a certain distance. So if you have the standard solar radiation which is flowing through a cold convection while the radiation is flowing down and the convection is coming down, this is when the temperature of the air and the ground are decreasing, but in an inversion form. But the time the air temperature reaches the dew point phase, then you have this cloud formation. Now, if this cloud formation is there, the flow of radiation is very, very difficult. And even if it is there, for us to estimate or model that during empirical processes, it's very difficult. So despite these well-known importances, it's still rare to understand these influences throughout the different compositions. One of the biggest challenges is that you don't have sensors which are constantly measuring its work because they are unbelievably expensive, roughly ranging from 60 lakhs or further beyond for one location, and the uncertainty which this climate change is influencing of the clouds, the aerosols, and the effects which lead to modeling and prediction errors. So if you have a sensor, this particular sensor is taken from one of the sites that we are working on. This sensor measures the incoming long wave, short wave, and outgoing long wave, short wave, the complete net radiation throughout. It's known as a pyrogeometer and a pyranometer combined. Now, this particular sensor, as a part of the ISRO Encompass program, which was a joint venture with London University, there are currently 5 major sites where this data set or this sensor has been deployed for their unique agroclimatic zones, from natural savanna grass to agricultural lands to rice fields. Because their climatic type is ranging from arid to wet to tropical humid and others, these things can be combinedly incorporated to predict over India itself. While we were understanding the influences or the parameters which were going through what is happening, we realized that there are a lot of key variables which are influencing these parameters. One of the astonishing factors that we realized was elevation itself. Because these parameters are being, or these sensors are being deployed at different locations ranging from 39 meters to 600 meters from mean sea level, the variation because of elevation is very, very strong. Aside from that, the standard air temperature and relative humidity were also playing a factor because fog also depends directly on these two. So aside from these, while we were trying to estimate or predict these variables over a large time, then building a model which can predict throughout the Indian landmass, we realized that multivariate regression or direct linear regression is not providing substantial data, which weren't even crossing the 50% accuracy mark. We shifted our idea to neural networks, and we realized that it is a computational model which, as the definition goes, is a biological neural network of the human brain and how it functions. Where you have the standard inputs depending on the parameters that you're looking for, with each of them having a direct linear relation based on the weights that you have. The transfer function talks about how the non-linearity is being influenced. Now, when you're talking about non-linearity, it is the inter-influence of the parameters amongst themselves before it is touching the final variable that you're looking at. So these non-linearities are being accepted and induced within the model, and the activation function based on the threshold that we define or whatever parameter we're looking at provides the necessary result. So if you look at the neural network that we have developed, you have the standard inputs that I previously defined, where there are 6 inputs, where each of them is being defined as a different weight for 2 different situations. One we're talking during the day, the second one we're talking during the night. The 11+ Markov model, which talks about high stability and faster accuracy with a single hidden layer. Now, a second layer was considered. However, the amount of accuracy that we achieved was comparatively less, but the computation time was significantly increasing. So we able to this for a single layer, and gradually we are going to extrapolate it further. It will forward back propagation increases the accuracy assessment and reduces the amount of errors that we talk about, because the single input is directly driven into the training model itself. And based on the sigma function that we have, where you have the non-linearity being brought back to the linear form, the incoming longer is driven. So we went from 0 parameters to 1, going up till all up to 8 parameters to identify how much influence of each parameter is there and what way can the accuracy gradually increase. During the day, we saw that after 6 parameters or after 5 parameters being
You have 1 minute to conclude. 1 minute to conclude. 1 minute to conclude.
Sure. Based on which we identified there were 5 parameters which were enough, and based on which we identified the results and the errors, where the accuracy starts being 90% and 86% with errors less than 0.1 and maximum due to some anomaly which was identified. You can see in the cluster graph here. What we understood was that few neural networks, while they were developed, we are still planning to perform them strongly on different sites. Right now they are on site, and we are planning to build this or extrapolate this over a spatial platform, so it can predict at every single place throughout the country by adding more and more sites onto this. Thank you.
Any questions from panelists, sir? Narayan, sir?
Sorry?
Yeah, sorry, I was on mute while he was speaking, and then, yeah, they will come. So, thank you, Donil, for your presentation, interesting presentation.
Thank you, sir.
So, I think one of the parameters you mentioned was elevation, right? Which was proving to be a fairly significant variable, right? That you correlated to, and that comes about because the air temperature is low. As it warms up, the dew point, that inversion thing happens a lot more frequently. So that's kind of validated by a model like this.
Yes, sir. Yes, sir.
Now, so you have now trained this data based off those 5 geographies, right? That you identified. I think one was Dharwad and a few other places, right? So if you were to take this model and take your equipment to a similar location, similar elevation and similar type of geography, were you able to validate to see how accurate the model is, or are there any other additional unknowns that would come in? Have you had the opportunity to do that yet?
Yes, sir. Yes, sir. I physically went to most of the sites to validate my accuracy on this. Since it is a joint venture, I only went to 3 out of the 5 sites. The accuracy is very close. We are getting an estimated error of less than 3% right now. In 3 of the sites. In the other 2 sites, there is going up to 6%, whereas the diurnal performance is very close by. So once we plan to extrapolate this on an image grid, we are planning to compare it with the global models which are already available. So we are planning to build it stronger that way and see if there is any possible biases, if there are any on spatial front. But on a point scale, physically going there, it is providing 85 to 86% accuracy.
Okay. And so your expectation is that it should work in a completely new location with similar characteristics, just to validate that it isn't overfitted in any form.
Yes, sir. Yes, sir. That is actually in progress, which is why I haven't added within the paper
Okay.
when I was submitting here. We
Okay.
are still in the process of finishing this.
Okay. And this activation functions, anything other than the regular sigmoid that you're planning to use? Because the sigmoid
Yes.
has a limited sensitivity range. So,
Yes, sir. Actually, what we are planning is I have actually tried the Danhel's function and the ReLU model as well.
okay.
However, the problem in both of them was that after a certain point, since my values expected value should be 600, around 350 or less than that, both of the models, both of the activation functions were failing to perform. So the accuracy was going less than 63%. That was the highest either of them could achieve. We experimented multiply with all the activation and the transfer functions. However, this was the best fit combination we realized, and now we are comparing how and why this has happened.
Okay. Yeah, it'll be interesting to see if there's a human understandable logical reason. But anyway.
Yes, sir. Yeah.
Okay. Thank you.
Thank you,
Thanks, Samuel. So moving forward, we have paper ID 250, Naveen Desai.
Yeah. Can I share now?
Yeah, please.
Okay, fine. My screen is visible?
Yes, can you make it a slide show mode?
Okay, fine. Now it's okay?
Yeah, please, sir.
Yeah. Shall I go ahead?
Yeah.
Go ahead, please.
Yeah. Thank you. Hello, everyone. Today I am presenting a paper on design and fabrication of indigenous low-cost water filter using activated carbon prepared from low-cost materials. My co-authors are B.M. Angadi, Department of Mechanical Engineering, BLDEA'S V.P.Dr.P.G.Halakatti, Vijayapur, M.N. Hiremat, Department of Civil Engineering, PESITM, Shivamogga. Yeah. Contents of my presentation includes introductions, materials and methodology, results and discussion, conclusion, and finally reference. So introduction. As we all know, water is one of the most important substance on earth. All plants and animals must have water to survive. The major sources of drinking water are groundwater and surface water. As this study deals with the groundwater, mainly I focus on the groundwater. In the present days, as we have observed that the groundwater is depleting and as well as it is contaminating, or I can say it is getting polluting. The major sources of groundwater pollutions I can list as an excessive usage of pesticides, lack of sanitation, then excessive pumping of groundwater. Coming to the Indian scenario about the groundwater, for the past 3 decades, it has been observed that by doing over pumping, there is for the irrigation purpose, there is a groundwater depletions. And what are all the negative? That is the things due to the groundwater depletions are deteriorations of water quality, then increased pumping cost and drying up of wells. Then coming to the here, 80% of India, that is I can say 1.35 billion residents depends on groundwater for both drinking and irrigation. So one of the government studies shown that 1/3 of India's groundwater reserves are being pumped at a faster rate than the recharge by rain. So as most Indian rural areas, people are depending on groundwater as their source of drinking water. Generally, groundwater is contaminated with, I can say, total hardness, chloride, fluoride, iron, acidity, and alkalinity. The reason for these contamination may be this is a geological structures at the area, then anthropogenic activities as we have discussed in the first slide. Then next one is and the depth of the well. So coming to the objective of the study, as our main objective was to design and fabricate of a low cost water filter, keeping in that mind we have given here objectives First one is that is the physico-chemical analysis of groundwater characteristics, such as we have measured that is the hardness, chlorides, alkalinity and acidity, and we have planned to treat these parameters with a naturally available low-cost adsorbent, that is a areca nut husk. Second objective, that is characterization study of this areca nut husk using a SEM. So in the SEM we have analyzed, that is SEM images we have analyzed, that is a surface area, pore volume, ash content and moisture content. And final objective we have kept as a construction of indigenous filter using a mud pot and locally available sand and sponges are as a filter media. So coming to the materials and methodology, here sample collections. Groundwater samples are collected from 3 villages of Shimoga Taluk. Those are Tevara Chetnahalli, Suruguru and Melina Hansawadi. All these samples collected from boreholes. These are boreholes. After analysis of water parameters in the laboratory, it was observed that Tevara Chetnahalli village water is more contaminated in compared to the other 2 villages. Therefore, this village water is selected for the study. Then coming to the preparation of areca nut husk activated carbon. In Shimoga district, we find areca nut abundantly. That's why we have taken, as it is called as a even agricultural waste also into the Shimoga, so that we have selected this areca nut husk for preparation of our activated carbon. So here I have shown the cost comparison with a prepared activated carbon prepared by the areca nut husk and as well as the commercially available, that is a activated alumina. If we prepare a activated carbon by the areca nut husk, the cost will come around rupees 265 per kg. And if we are going to purchase a commercial activated alumina, that comes around rupees 965. As our project is going to mention the low cost. So here, this is the difference you can able to see over here. So with this, we can able to treat even 250 liters of water without decreasing the efficiency of areca nut husk activated carbon. So the next thing, I am moving towards the filter preparation. For construction of a water filter, locally available sand, sponges and mud pots are used. The top and bottom of the cartridge is filled with the sand and activated carbon respectively, and a 1 centimeter sponge is placed between the each layer of activated carbon as shown in here figure. This is the total we have used. This is the activated carbon over here of 4 centimeter, and here sand we have used of 4 centimeter in between the sand and activated carbon, so that it should not get slipped over here. So we have used here a sponge. The amount of activated carbon and the sand taken to fill the cartridge is 40 gram and 60 gram respectively, which are filled layer wise. So coming to the construction of this is the mud water filter. Water samples are poured into the upper part of the filtration unit. Subsequent water comes into contact with the filtration media presented in the cartridge and filters through it. Whatever the treated water is there, it is going to collect at the bottom of the mud pot. So we have provided a tap over there, so we can able to collect the treated water through this tap. Then coming to the results and discussion, I am presenting in 2 parts. The first part, I am going to discuss about the characteristics of prepared activated carbon. The prepared activated carbons are analyzed with some images. These some images we have taken it from the NITK Surathkal. The first some image shows after analysis, it is observed that 75 mm passing carbon and 90 mm retaining. The surface area of activated carbon passing through 75 mm and 90 mm found, that is of 183.73, and 90 mm retaining here it is a 169.43. So as this is having a more surface area, so we have selected a 75 mm passing, that is activated carbon for our study. So here with these some images we can able to see the clear surface textures and porosity with holes and small openings. This indicates, you can see over here it into these two pictures, this indicates that this type of surface contact area increases and facilitator for pore diffusion during adsorption. The low moisture content here, that is the ash content and as well as the moisture content, also we have calculated. The low moisture content and ash content indicate that the particle density is relatively small and the biomaterial should be the best raw material to use as a adsorbent. As we know, the low moisture content and the ash content indicates if the ash content is higher, then it implies the activation of activated carbon, and that is using a sum of additional load of carbons. So this is all about the characteristics of prepared activated carbon. Now coming to the groundwater physicochemical analysis. According to IS 10500/2012, the hardness of the water is above the desirable limit. It should be of around 200 mg per liter, but here it is showing of around 262.3 mg per liter. The alkalinity desirable limit, and the alkalinity after the treatment, it has the desirable limit comes around 145 mg per liter. So I can say that here the hardness is 200 mg per liter as per the IS 10500 for drinking water, and even alkalinity limit is also for that is of 200 mg per liter. After treatment, we can able to see that the reduction of alkalinity, that is of 145 mg per liter. So it is making for the alkalinity, it is water is potable water. So even we have shown it into the percentage of removal, chlorides, total hardness, alkalinity, acidity in the percentage. The maximum that we have can able to remove 34% of alkalinity and 40% of acidity, even 24.35% of chloride. But we are not achieved good results in removing of total hardness. We can say around 6.5% of only we can able to remove the total hardness. So these results we have correlated with the value of pH, as the pH is the one of the important factor. So whenever we have collected the water, the initial pH of the sample of water was found to be of 7.52. With the literature and as well as our study shows that chloride removal decreases in the acidic and alkaline phase. If it is a less than, that is a 7, then it is there is a chloride removal, and as even in alkaline phase also it is a removal efficiency is going to get decreased. Similarly, for the hardness removal efficiency by activated carbon is increased with a increase in pH. So if the water's pH is higher, then hardness we can able to remove in a maximum quantity. And finally I can say that there is no mineral acidity in the collected groundwater, and only we have got, that is the CO2 acidity is present, and this CO2 acidity we can able to remove around 40% by activated carbon. So finally, coming to the conclusion drawn from the study, the results indicates that areca nut husk can be used efficiently for the preparation of activated carbon. The surface area of the prepared activated carbon passing through 75 mm and 90 mm found to be 183.73 square meter per gram, and as well as 169.43 square meter per gram respectively. The same images, even it is shown that activated carbon has a high porosity and high pore volume of activated carbon.
I mean, you're trying to.
Okay, fine. The moisture and ash content in the activated carbon were found to be low for activated carbon prepared from areca nut husk. And finally, I can say that activated carbon made from the areca nut husk is able to remove chloride, alkalinity and acidity. Not much it is contributed in removal of total hardness. In between, that is the pH 7 to 8. The locally developed filter unit is environmental friendly and cost effective, I can say at the end. So these are the references which we have used to prepare this paper. Okay, thank you.
That is a very interesting paper, and I appreciate the work that you have taken in looking at a cost factor perspective, looking at more detailed analysis, coming out transparently with all the results, some of which are good, some of which need improvement. I think that is a good approach to take. So I wanted to ask you one thing is, in your study and results, and you created that mud pot with all those layers, so that's good. What is the lifetime of this? I mean, after how much time do I have to replace that activated carbon layer so that it remains effective in treatment?
We can able to filter around 250 liters of water, sir. 250 liters. Then
okay.
We have to charge it out, or we can.
Then you have to charge it out. So it's almost on what, a daily to few days.
No, we have made it for the household actually. Yeah. So we can have around 10 to 15 liters of water. We can able to get it every day from the household for drinking purpose and all those things. So it's not for things which we have prepared it for, mainly for the local village peoples.
Okay. Got it. And yeah, okay. This is good. I mean, I think as you do more studies, more research to improve some of the factors like hardness and so on, that will be very useful. Ashok, any questions for anybody else? You're on mute, Ashok.
Sorry. Yeah. So the question here is that you mentioned that this is designed for the villages. Now, can this activated charcoal be produced at the local level?
Yes,
what
sir.
Is required to do that?
It is prepared in the laboratory only. Our laboratory by.
Can it be done at the village level?
We can, because the cost which we have calculated by preparing it into the lab, that is whatever the chemicals we have used and all those things, it came around 250 rupees. So we can able to even prepare it into the village level also, sir. So the procedure we need to implement, or we need to communicate them how to prepare these other things, because some of the, I can say, equipments are also required for this, like a dry oven. Then muffle furnace is there required. So we have to have a lab for preparing of these type of activated carbon, actually, what I feel.
Okay. And how are these activated carbons different from the activated carbons that we use in gasifiers, like that come out of the gasifier, wood-based activated carbons? Is there a comparison you have done?
Exactly, no, but it is a natural what we have taken it out. Exactly, we have not done any comparison study, but when we have gone through the literature, there will be a lot of things have been done by the other these activated carbons. I can say that coconut shell they have used, even rice husk they have used, all these things they have used it for preparing of these activated carbon, and this is the area which is not explored actually, so we have thought it to go ahead with this areca nut husk.
Agreed, but try to do a comparison as well. How is it better? How is it worse? And also the commercialization potential. When you're talking about villages.
We have. Can we go ahead?
Yeah, thank you.
Okay, thank you.
Thank you. So next we have paper ID 265. Aditya, can you hear us? Hello?
Hello?
Yes, we can.
Am I audible?
Yes, you're audible.
Yeah. The PPT is visible, right?
Yes, the PPT is visible. Can you make it? Yeah, it's done. Please, sir.
Okay. Myself, Orithro Ray, from AKCSIT, University of Calcutta, would be presenting our paper, SWIM, Smart Secured IoT Framework for Integrated Water Resource Management System. The work is in collaboration with Center for Development of Advanced Computing, CDAC Kolkata, which is a Government of India organization. Right. So this paper and presentation today is the upgradation or continuation of the work which was already published in another IEEE conference, that was the International Conference on Power Electronics and IoT Applications in Renewable Energy and its Control, and the paper is currently available in IEEE Explore Digital Library. So what we're basically looking to do is that there is a global crisis looming over us pertaining to the freshwater supply, which draws upon itself the need for developing a system that could cater to it. The developed systems need to be smart enough with the use of machine learning so as to detect excessive or normal water flow through a water pipe. The data must always be end-to-end encrypted so as to ensure the confidentiality and security in the water usage pattern. And it must be able to be deployed across a large area, say for instance a state or a country, and wherein every water pipeline must be connected in the network so as to maintain the water resource usage of India at large. And again, this would make enough data to come into the system from all the water pipes that are connected, and therefore there has to be a split or a distributed computing facilities inbuilt in the network, which we have integrated in our solution. And therefore we can say that we have been able to develop an intelligent, low-powered, and a sort of commercially deployable device after some field tests, which can be used to monitor the water usage in urban areas for a large area like a state or a country. So basically, what are the major drawbacks in the existing system is that it is not feasible for a very large scale implementation because of the single point failure. That is, there is too much of emphasis given in the edge node computations and the absence of the fog computing layers. And apart from that, there's an absence of a security module or the security protocols, which, like for instance, would make the system vulnerable and have people to get unsolicited access to the same. And again, water is a national property, and the usage pattern data, if leaked to other people, can prove to be detrimental for both the country and the implementation organization. And again, we have basically used the AES encryption scheme, which can basically handle the exhaustive key search computation compared to others like DS, and is comparatively less resource intensive, as well as provides a good security scheme that we have considered in our study. And again, the other aspect is this, that based on the implementation and the water usage that is available, the implementing organization, be it the government or some other body, can definitely charge or have some tariffs to, like the electricity bills we get, we can basically have tariffs on the water usage that we are having for that particular area or that particular household. So therefore, we have basically shown that this is a swim stack technology. We have the Wi-Fi communication modules through which the communication is based on that, and the forward sensor microcontroller, which basically takes the data, it sends it to the fog where there is a computational ability. And again, in the cloud computing, we have used a commercially available cloud, that is a ThinkSpeak based on MATLAB. So therefore, we can have the computational abilities, the data visualization, and specifically sending of alerts to both the concerned household who is basically using excessive water for that particular time frame, as well as notify the implementing organization, say for instance the government or any other organization, who is basically will be controlling the entire thing. And again, there will be specified channels and specified login IDs for those, that is the government or whoever is basically implementing can have access to all the data, whereas that particular person can only get access or view the data for his or her particular household or that particular housing complex wherever needed. Now, this is basically the security layer that we have used. Again, we have used the basic encryption AES 120.
Aditra, just 1 second, please. Could you just go back just to the title for your presentation?
So SWIM, Smart Secured IoT Framework for Integrated Water Resource Management System.
Okay. Yeah, go ahead, please. I'm sorry. Go ahead.
Yeah, okay, sir. So basically, this is the security layer that we have used so as to make the end-to-end encryption. And this is the AES encryption. We have used the AES 128 scheme. And again, once we go higher the number of schemes, once we have a commercial deployment, the framework is definitely ready. And we can upgrade the security from 128 to number of higher bits so as to ensure that there is more number of security. The entire details procedure, as in how it is being performed, it is the byte substitution and the shift row operation and all other functions are depicted in the slide. And if we go in the reverse fashion, we have the decryption. So this is the most important slide, as I feel that this is the proposed architecture that we are proposing. So at first we can see that there is a data acquisition unit from where we are basically taking the data and having some little bit of computational benefits there, like we can have some filtering procedure so that if there is a sudden jerk or something in the data, if there is noise in the data, we can cut it out. And that particular data, we are encrypting it and sending it to the fog node. Again, if there is a too much amount of many edge nodes are basically connected to the fog node, and therefore there is a particular time interval or a polling rate. We calculate that average, and based on that average, what is the water usage, we push it. That encrypted data is basically pushed into the fog node. So there are multiple amount of edge nodes which are basically connected to the fog node. And again, the data transmission is encrypted. At the fog node, we decrypt the data, we perform the computation. So what kind of computation we perform? The fog nodes are basically made intelligent, and it basically computes the highest water rate consumption for that particular period of time. So it does not go on the historical data. The fog nodes goes by the present data, whatever it has been received. And based on that, it sets a priority, which is a kind of a scheduling algorithm problem. So which data will it push at first to the cloud? And based on that, the fog nodes will basically push the data into the ThingSpeak cloud, into that particular channel. And ThingSpeak is again commercially deployable, and with more number of channels can be created with more amount of subscriptions and stuff like that. And again, we have performed some machine learning algorithms. So based on the machine learning algorithms, it can basically detect. Now it focuses on the historical data because it's a cloud. It has a lot of amount of storage and everything. So it focuses on the historical data and finds out where is the excessive amount of water usage. And based on that, on the channels, we can have the visualization, and alerts are sent only to the registered email IDs by the IEEE or the webhooks platform. So again, that is a very secure communication protocol through which we are sending alerts to all the registered email IDs for that particular channel or that particular, it actually boils down to that particular node from where there is an excessive water usage. So this is basically the architecture. And now I will move on to, this is basically the data acquisition module from where we are actually getting the data. And from here, we basically have the result section. If you can see, this is the prototype that we have developed. Again, as I have already mentioned, this is a low power device. Therefore, it can also operate on the solar panel, the top here on the device here. This is basically the solar panel that we have. And this is a water flow sensor connected here, and the water is basically flowing through this. And again, here you can see that basically the data transmission is taking place from the edge node to the fog node, and it is again encrypted. So this is the encrypted data that is being transferred, and at a certain polling rate. So here we can see basically the data visualization in the MATLAB plot output, which is basically taken from the ThingSpeak cloud platform. And basically at a given time instance, we can see what was the what was the flow rate at that particular time. And integrating this, we basically get what is using the TRAPZ function, which is again the code is very easy to maintain in the commercial cloud platform of ThingSpeak. And from there, we can basically find what is the water usage for that particular time. So we can basically define from 10:30 to 5:30 what is the water usage for that particular node, and we can get that. And again, we have used a simple logistic regression model. Again, with more and more amount of data, we can use more higher computational intensive models. And here we can see that here, based on the old data, that is the historical data, it can basically detect what is the excessive flow and the normal flow. And based on which we basically have the alert mechanism, which is sent out. This is the email that you can see that is sent out to the webhooks IEEE platform. Now, two things to be mentioned here. Basically, one is that excessive water flow. So whenever we are looking at an excessive water flow, it could be either the excessive water flow for a particular usage, that is, a particular household is using more water than the other one, so that could be excessive, and also there could be pipeline damage. That is, a major pipeline has broken out and there is an excessive surge of water that is going out. So we need to be able to detect that, and basically we get more historical data and we can actually find out the pattern, and the pattern will definitely be a little different, because if there is a certain water pipeline damage and there is a gush of water that flows out of it, that pattern will definitely be different from what pattern we will have if the particular household basically uses a different, basically has a excessive water flow. And the second one that I would like to mention is the use of machine learning in our application to differentiate the normal and excessive water flow is for each pipe based on the training data. It is also important because what is excessive for one pipe or one household may not be for another, and that can be the water. Basically, the water usage pattern can basically depend on a variety of factors like the geographical location, the population density of that area, or whether it does like many other different factors, or whether that particular is a say for instance it's a stadium or it's a cafeteria, it's a particular household. So based on that, we are trying to create a generic model that can be deployed across all the commercial house or even in case of the domestic households. So again, the future scope of work is the sensors, whatever sensors we are using, there could be internet issues, and then the data could not be transferred from the edge node to the cloud or to the fog nodes, and therefore we can have memory modules to store those particular data in that fog node, and whenever that whenever internet is.
Sorry, 30 seconds to conclude.
Yeah, okay. I'm completing. So once we get that data, that could be pushed out into the from the edge nodes to the fog, and again there could be damage due to environmental factors and other things. So those things need to be kept in mind when we are implementing the solution. So these are some of the references that we have used in our paper, and thank you, and looking forward for some questions.
Thank you, Aritra. I guess the key part for your papers is leverage a standard model for edge and fog and to build additional security around that. Is that right?
Yes, and also use the machine learning to differentiate between the excessive and the normal water flow, and again excessive has different kinds that I have mentioned.
Okay. All right. Okay. Ashok, any questions for you?
So, I was just wondering, where are you going to put this security stack? It is on your IoT devices, or it is on the cloud?
Can you please come again, sir?
Somewhere in between, I guess.
Yeah, go ahead.
Go ahead.
Yeah, sir, can you please come again with your question, please?
I'm saying your security devices at the IoT level, at the cloud level, where? I think it should be at the device level, right?
Yes, sir, it is at the device level. Whenever there is data transfer, it is being sent from whenever there is transmission across from the edge to the fog and fog to the cloud, so there the encryption part is being taken place. And again, one thing to be mentioned that we are considering that these nodes are secure. There's a latest encryption modules that they're trying to work out, which is the homomorphic encryption. Again, it requires more amount of computational power, but if needed, we can also implement that, for which we can perform the computations at the fog, edge, and the cloud.
Got it. So your contribution is essentially the encryption algorithm. What is your contribution in this?
My contribution is basically to build this framework, and given the technologies that we have, and again to have a split in the machine learning algorithms and the different types of things that we are trying to implement, the objectives that we are trying to fulfill, that is to bring out the excessive water flow and to notify the users and to notify the authorities that at this particular location there is more water usage. So maybe the government or the implementing organization can come up and have a word with the households or people like that, so as to reduce and so as to have a check on the water usage. And secondly, to monitor that if there is a water pipeline damage at particular instance, and immediately notify so that we can lessen and have a sustainable society.
Okay.
Okay. Thank you, Aritra. I'll, ping me offline. I'll send you some other standard reference models and architectures. Thank you.
Thank you. So moving forward, we have paper ID 205 that.
Yeah. Okay. Okay. All right.
So.
Hello, sir. Is it audible, sir?
Yes.
Yes, sir. I will share the screen. Huh, sir. Is it, sir?
Not yet.
Not yet. Yeah. No.
Yeah.
Can you write?
Yes. Hello.
Yeah, please go ahead.
Sir. Myself, Mutan Breaker. So I'm studying B in Electrical Electronics Engineering, BLDEA'S Vijayapur. So today I'm going to present my paper, that is implementation of automated water supply and distribution using PLC and SCADA. So the first author of this paper is Amjad, sir. So let's see. These are the contents which you have: introduction, block diagram, working principles, and results, advantages, conclusion. Uniform water balance is must to meet out the increasing population of the world in order to avoid water imbalance and consumption in future times. Yes, in every country, the potable drinking water plays a very vital role. So we have to balance water uniformly, and also we can avoid the water imbalance, and we have to save the water for future times. Monitoring of the water prevents water theft and water leakage successfully. Yes, with the help of using the SCADA and PLC, we can prevent the water theft as well as water leakage successfully. Therefore, monitoring activity has become a great focus in present days to provide the link between water supplier and consumer. Yes, it provides an link between the water supplier as well as the consumer. Next, automated model has to be used which enhance the filtration, improves the storage distribution, and decrease the water wastage and water theft. With the help of these techniques, we can also improve the storage distribution and filtration, and we can decrease the water wastage and water theft. You can see here the block diagram, which it contains the main supply, MCB, SMPS. This is a PLC, which are using for program control operation. And here is a service tank, buzzer. This is in distribution network 1, distribution network 2, main distribution and pump have used. So let's see the working principle, how it works. So the main supply usually is 230 volt AC volt, which is connected to the MCB. MCB is nothing but it is a miniature circuit breaker. So it will protect the all interconnected devices. So through MCB, it is fed to the SMPS. It is a simple mode power supply, switch mode power supply. So it will switches to AC to DC. For example, for house purpose, as we are using a 230 volt AC supply, so it will convert to DC for 20 volts. So which it is fed to the PLC. Next, through PLC, in service tank, you can see here, here is the low sensor, middle sensor, and high sensor. When the water is at low sensor, automatically it gives the information to the operator through using the GSM to refill the tank through the pump. So when the water level reaches to the mid-level sensor, automatically same process, it will give the information to the operator in the form of GSM as well as the buzzer to refill the tank. So finally, when the water reaches to the high level sensor, at that time, it also gives the information to the pump to stop the refilling the tank, as well as the whatever DN1 network, this is in distribution network 1, distribution network 2, where they are continuously flow of water. It will be by using the what we can use the solenoid valve we are used for continuous flow of water. And you can also see that we can identify the water theft. So for water theft, we have used the flow sensor. Here as you are connected between service tank and DN1 and DN2. So let's see next slide. You can see here the results. At particular level, different operation will be takes place. So when water level in the main tank is above the mid-level sensor, distribution valve will be open and water is distributed to SV1 and SV2. They are both a solenoid valves. So when the water level in the main tank reaches the high level sensor, so when it reaches to high level, the motor will automatically stop the pumping water, but distribution will be on till water level reaches to below mid-level sensor. So when water level in the main tank is below the mid-level sensor, pump will on and start to refilling the tank. You can see this is an PLC program and SCADA. SCADA is actually, we can see whatever operations are going on in SCADA. As we are given the commands, that is for start purpose, as we are using the input and output commands for start the pump, for stop the pump. So for identification of graphical representation regarding the program, you can see here. So green color which indicates the start. Yes, here. For green color, which indicates the start, and for stop purpose, there indicates the red. And also inlet valve diagram, solenoid valve, and pump. Here is the next. You can see here low level, mid level, high level sensor. At particular level, particular operation takes place depend upon the level of the water. So DN1 and DN2 it will operate. So we can see the overall advantages what we have regarding by facilitating the monitoring and control systems. So unskilled operator can easily understand and restore the data for graphical interface, which is more advantageous. Yes, even unskilled operator can also be easily he can understood and can operate. This is also more advantageous. So real-time water theft identification, around 75% of water loss can be saved. Yes, during real time, the water theft identification easily can do by using the PLC and SCADA software, and around 75% of water loss can be saved. Next, improves the water purification, storage, supply facility. Yes, with the help of using this, we can also improve the water purification. Also, we can store the water and supply the water continuously without interruption 24/7. Next, on fault occurrence, alarms are created to the alert to the operator using GSM facility in the form of messages. Yes, when there is a fault in the system, when the fault in the regarding the output, whatever we have distributed the water, if is there any fault, automatically it gives the information to the operator through GSM. Cost effective for controlling difficult systems. Yes, this is very important. It is cost effective for controlling the difficult systems. Next, flexible to control other systems easily and quickly. Yes, with the help of this SCADA and PLC, we can easily control quickly as well as very fast. Troubleshooting the helps programming easy and reduce the downtime. Yes, with the help of troubleshooting, it is easier to do the programming as well as reduce the downtime. Lastly, conclusion that the automation of water distribution model provides unbroken water flow and eliminates the water wastage. Yes, with the help of these techniques, we can control overall the systems by using PLC and SCADA, and also we can supply the water without interruption, as well as we have to eliminate the water wastages. So overall, this paper explains automatic techniques and minimize the human power, avoid the reduced time, water theft in the water pipeline. Yes, with the help of this, we can also reduce the time. Also, we can save the time, and also we can avoid water theft in the water pipelines. Public will get the same share of water. Yes, this is also very important. There is no yes, there is a same share of water will be shared. System is cost effective and excellent. The system is very cost effective as well as excellent. It provides continuous water distribution to the public. Yes, this plays in very important. We can distribute the water to the public without interruption 24/7. We can continuously with purified water, and also it is very easy. We can identify the theft as well as leakage of water. Thank you, sir.
Thank you. Is there any this was implemented as part of project?
Yes, sir. Actually, as we have done, this is the prototype, but it is implemented, sir.
Okay. And anything when you compare with other existing solutions, any new ideas that you have been able to discover or come up with?
Sir, actually, which we have done, it is new techniques which are used. Sir, because while coming for urban and rural areas, this is not implemented, sir. But they are well developed. But these types of systems are not implemented. But in future, we have to going to implement this system, sir.
Okay. All right. Thank you.
Thank you, sir.
Ashok, any questions for you? You have?
I don't have.
Sure.
Yes, we don't have. So moving forward, we have paper ID 327.
Thank you, sir.
Yeah, thank you.
Who's next?
Paper ID 327, sir.
Yes, sir. Good morning, sir.
Yeah, good morning. Good afternoon.
Can you share your screen, please?
What is the paper ID, Advait?
327, sir.
327.
327. Okay.
Yes, sir.
And we have one more after this, right?
Yes, sir. Only one more.
Okay.
Dr. Are they able to
Yes, I am trying to share the PPT.
Yes.
Sir, can you see this PPT, my presentation?
Not yet.
No.
Just a minute. Sir, is it visible now, sir?
Yes, yes.
Is it visible? Huh?
Well, can you make it
Yes. Thank you. Thank you very much.
Yes, please.
Very good afternoon to all of you. Myself, Mr. Totappa Sarmani, research scholar from Vijayapur University College of Engineering, Pune, presenting my research paper, Optimum Sizing and Performance Assessment of Solar PV DG Hybrid System, particularly designed for energy self-sufficiency of Jaggery making units. Along with my co-authors, my guide, Dr. Rajesh Holmuke, and other co-authors, Dr. Abhishek Gandhar and Dr. Shikha Bharadwaj, in an IEEE B-HTC 2020 conference, and my paper ID is 327. My presentation outlines are shown here. First chapter is regarding the paper title, then the second chapter is literature survey. Third important chapter is about the research methodology which we followed. Then the fourth is simulation. Simulation results which we have used the PVC simulation software, and the results are shown here. Then the fifth is conclusion and scope of the future work, followed by acknowledgement and references, and if time permits we can also mention some of the achievements. So it is about the jaggery making unit or jaggery. Jaggery is unpurified sugar produced by boiling of sugarcane juice in a bagasse fired can furnace heating system. Jaggery is one of the most popular small scale business enterprises that provides local job employability in rural India. It has a nutritional value and it mainly contains sucrose, glucose, fructose, and very important minerals like iron, calcium, phosphorus, magnesium, protein, and other traces of zinc and copper. Now, why this study is required? That is, the scope of study is India is one of the leading exporter of the jaggery, and in year 2019-20 itself, India has exported around 341 metric ton of jaggery of worth rupees 1600 crore rupees. However, improper designing of conventional jaggery units leads to lower thermal efficiency and insufficiency of bagasse. Similarly, optimum sizing of bagasse is of great importance because the bagasse has a higher calorific value and it can be used for manufacturing of the biofuels like bioethanol, methane, and bio-CNG. And these bio-CNG have a potential to replace the commercial CNG and LPG and other transport fuels which the country is importing from the other countries. At the same time, jaggery units are located in remote rural areas where there is a lack of grid electrical supply. Therefore, farmers are mostly using the DG sets, which are causing greenhouse gas emission and tremendous environment pollution. Thus, future demand for fuels makes convincing case for research in energy efficient jaggery making unit and use of renewable energy source, mainly solar energy in this sector. The research outcome for the main objectives of this research paper or entire research is design and development of cost-effective energy efficient jaggery unit of 30 TCD ton crushing per day for a farmer producer group. Design of optimally sized solar PV DG hybrid system for this energy efficient jaggery unit. And we are also discussing about the design and development of prototype of PLC-based power generation controller for this solar PV-DG hybrid system. Then there will be performance assessment. Then we have surveyed so many literature papers and they are tabulated here. In this case, the worth mentioning are I have personally visited IIT professors, particularly Vishal Sardeshpande sir, Milind Rane sir, Dr. K. Chiralkar sir, and Dr. Sanjay Mahajani sir. They are professor in mechanical and energy department of IIT Bombay. And at the same time, I met Dr. Talange sir, Dhananjay Talange, COEP Pune. And I took advice from these people so as to carry my research in this area. And then these are the major research findings. Then as per now we are coming to research methodology. In this case, as per their suggestion, I first of all started the field survey of various jaggery making units, their technology used, and I surveyed so many jaggery units. Some of the worth mentioning are listed here. Bhama Organic, Srikant Agro Industry, then Vijayalakshmi Jaggery, and the Gauri Organic, and Doddanwar Jaggery. So their crushing capacity, connected load, technology they are following, and some of the critical findings which I have observed there, they are listed here. Most of the units are 30 TCD, and the major critical findings are very high project cost. The project cost is ranging from 1 crore to 2 crore rupees, which is not possible for a single or a small farmer. And there at the same time there is no bagasse saving, because the bagasse has a very high calorific value, and if we save the bagasse, it will be useful for the farmers. Okay, and there is an oversized plant. If we see the semi-automatic plants or boiler-based plants, we have to install the boiler housing system, then the softeners. All these are required, and the cost goes in crores of rupees. So then we decided to design a cost-effective, energy-efficient jaggery unit which is capable of giving bagasse saving. At the same time, it should be energy self-sufficient. It should generate its own electricity. Okay, so accordingly, as per the literature survey which I mentioned previously, there is a concept called as mass energy balance equations. So according to those findings, we designed and developed a cost-effective, energy-efficient jaggery unit which is located in Solapur district of Maharashtra state. And these are the design specifications. These are the thermal specifications. Then this is the metronome value of that location, Solapur location. Okay. Then this is the entire project cost. I have given all the breakups here, and for example, machinery cost, sugarcane crusher, pan, then raw juice tank, all these things. And the beauty of this project is, the novelty of this project is, we are providing that DG, optimally sized DG, then the solar PV system. We are providing solar PV system of 10 kilowatt and PLC based power generation controller. So the entire cost of this project, including the plant shed, is just 12 lakh rupees, where compared to other projects which are ranging from 1 crore to 2 crore rupees. And at the same time, we tried to provide the government subsidy. There is a scheme called as PMEGP, Prime Minister Employment Generation Program, which is giving 35% subsidy to the farmer, and they have applied, and it is in process. And they are getting around 4,20,000 rupees, and the own contribution is just 7,80,000 rupees, which the farmer group can sustain. They can provide this much amount. Okay, so now why there is a need of PLC based controller for this solar PV DG hybrid system? As all of you know that solar system is a energy, it is intermittent in nature. It depends on the weather conditions. And this graph shows that PV curve of the solar cell shows that lower the radiation, solar radiation, then the power generation will be lesser. So in that case, what should be done? Because if the farmer is working on the isolated grid, then in that case, what should be done? So therefore, we are providing a solution, that is the power PLC based controller is given here. Here the CTs are mounted at the various locations, means on the load side, then the generation side, CTs are located, and they are sensing the load current as well as the power generated from the solar system as well as the DG system. And it is a schematic diagram. See here, and the PV panels is there. We have used the Fronius inverter. Then there is a DG capacity, DG is there, and PLC based controller, and it is the connected load of the energy efficient jaggery unit. And this is the hardware, which it is a prototype hardware which we have developed in Bharati Vidyapit. And if it is required for the farmers, then we will provide them. We will install these things at the very nominal cost, and without any profit gaining objective. Okay, so this is the specification of PLC based power generation controller which we have developed. Here the PLC is there, then the PLC analog 4-channel input module, then the relay card is there, SMPS, and all we have developed this prototype. And this is the solar PV DC hybrid system which we are installing at the farmer producer group in Solapur. Here number of models are given. Number of models are 30 models. Then the PV in series are 19, strings are 2. Then the model area, everything is given. And the energy need of this plant is just 44 kWh per day, and the total connected load is 8 kilowatt. However, to have to consider the future expansion, we are designing the power plant for the 10 kilowatt. Then these are the simulation results. For simulation, we have used the robust simulation tool that is called as PVC simulation tool. By this tool, we can do preliminary design, detailed project design. There is a tremendous databases available, and various tools are available, and we can design different configurations. That is grid connected system, off grid connected, that is called a standalone system, agriculture pump set system, DC grid, everything we can design. We can select the field orientation, whether it is fixed tilt or seasonally tilted or is automatic tilted. We can select all those things here. Then, and this is the main workspace of this PV simulation tool, where we can select the different configuration of the PV panels and the strings as well, inverters. Now, the main thing is simulation results. Here, we have designed a plant of 10 kilowatt peak. Nominal power plant is 10 kilowatt peak. And the losses are mentioned here, different losses. Here the main losses are, that is the PV losses, array collection losses 0.98 kWh per kilowatt peak per day, and the inverter loss is 0.11 kWh per kilowatt peak per day, and the energy generated by the plant is 4.58 kWh per kilowatt peak per day, and the performance ratio of the plant is more than 80%. Means higher the performance ratio, more efficient will be the system. The ideal is 100%, which cannot be achieved at any cost, because there are so many other maintenance things are related. And but
1 minute to conclude.
These are the balances and results of the plant. The plant is capable of generating 10 megawatt hour annually, out of which farmer is using around 6.5 megawatt, and in case of non-availability of solar energy, he is getting 10 kilowatt. However, the plant is generating 16.5 megawatt, means the plant is sufficient to generate all the electricity requirement. So these are the conclusions. Major conclusion and scope of future works are mentioned. We have designed and developed cost-effective energy efficient plant. We have saved the bagasse, and we have tried to give a PLC-based power generation controller, and all things are, and the GHG emission is reduced to 93%. Then further study is we can produce the biofuels like bio-CNG, methane, hydrogen, if the bagasse is by saved bagasse. And possibly we can also use the fuel cells in near future. These are the reference papers which we have used, and I personally met all the eminent personalities from the IIT. Some of these are the research achievements which may not be useful for this, but I am mentioning here. Various grants I have got. Then the MOUs we have signed. Then these are the international examinations which I have passed, and these are the site survey photographs. Okay, these are the sites, and this is the plant we have developed. I met the Greg Jackson from University of School. Yes, I'm finishing. Yes, thank you. Thanks a lot, sir.
So any questions from panelists? Sir, you're muted.
Sorry. Thank you, Dr.P.G.Halakatti, for this presentation. I have gone through your paper earlier on during the review.
Okay, sir. Yes, sir.
Right. So you have given a lot of detail in the paper and over here.
Yes.
My question for you is, given the time, 10-15 minutes, if you could next time just summarize it a little more, it will be easier for the rest of the audience also to follow. But I have seen, I have already reviewed your paper offline.
Yes, sir.
Thank you for your Thank
Thanks
you.
a lot, sir. Sir, just a minute. I won't take much more time. I want to thank Dr. Farooq Mistry, sir. At the same time, Nagendra Sinha, sir, and Dr. Ashok Das, sir, and all the eminent personalities which I met in this 3 days conference, specifically Bhakti Sharma and all those people. Thank you very much, sir. Thanks a lot.
Yes, please get in touch, sir. I'd like to know more about your work and how we can.
Sure, sir. Yes, sir. I will definitely contact you, sir. Thanks a lot. Okay.
This is a good stuff. Thank you.
Okay, sir. Thanks a lot, sir. Please.
Moving forward, we have paper ID 347. It's the last paper of the session. So we have Shamim Hassan. So, yeah.
Am I audible, sir?
And your screen is visible. Can you make it slideshow mode, please?
Yes, sir.
Please go ahead.
Thank you, sir. The topic of my presentation is Design and Comparative Feasibility Analysis of Optimized Hybrid Energy System for a Remote Island. I'm Shamim Hassan, working as lecturer, Department of Electrical and Electronic Engineering, Tripoli, at University of Liberal Arts, Bangladesh, popularly known as ULAB, Dhaka, Bangladesh. Contents of my presentation include objective, introduction, energy elements, estimation of loads, feasibility study of energy sources, conclusion, and future scope. As we all know, energy has become a necessity for our day-to-day life. Majority of the energy sources available in Bangladesh are supplied by fossil fuels. Considering the present storage and consumption rate, the amount of reserve coal will be over in near future. Over the globe, energy consumption from fossil fuel has shot up around 34%, according to the recent data. So due to the unavailability of fossil fuels in future, the utilization of renewable energy sources has become an urgent necessity. There are many remote offshore places in Bangladesh where the supply of electricity from a conventional grid-connected system is not yet available. Saint Martin is one of them. It is regarded as one of the most spectacular tourist attractions because it is one of the beautiful tourist spot and the only coral island in Bangladesh. In accordance with the census performed by the Information and Statistics Division under the Ministry of Planning in Bangladesh, this island has a population of around 4,000. Providing electricity to the mass people living in such a remote offshore area is a daunting task and of prime importance because the quality of life heavily depends on the significance of the availability of electricity. The electricity demand of this island was calculated as 1,350 megawatt hour per year. So an off-grid hybrid energy system can be an appropriate substitute to provide electricity to such area. The objective of this paper is to at first design, simulate and analyze a solar PV wind turbine based and secondly a solar PV wind turbine and diesel generator based hybrid system for the offshore remote island like Saint Martin. After that, these two configurations are compared on the basis of cost of energy and the better energy system for the Saint Martin Island is proposed. In this slide, we can see some graphical representation related to solar photovoltaics. There are certain energy elements that are used to design the hybrid energy model. Wind turbines, solar PV, diesel generator converters and batteries are used for this particular paper. For this island, we can see from figure 1, the average solar radiation in Bangladesh for different months is shown here, where the average value is 3.5 kilowatt hour per meter square. In figure 2, the clearness index for different places in Bangladesh, for different months in Bangladesh is displayed and the average value of the clearness index is 0.52. Now this slide is about the wind turbine and diesel generator. Bar graph of figure number 3, as you can see, bar graph of figure number 3 is showing the average wind speed in St. Martin's Island. June and July show high average wind speed as those are associated with the rainy season. The average wind speed is 4.6 meter per second in St. Martin's. For the hybrid system we are considering, the diesel generator is considered as a backup. The figure number 4 and 5 are related to the diesel generator characteristics. Figure 4 shows the relation between output power variation and fuel consumption, whereas the figure number 5 shows the efficiency of the diesel generator, which is around 40%. There are around 878 houses, 170 shops, 3 schools, 1 community clinic, and 15 hotels or resorts in St. Martin Island. Table 1 indicates the household load, electric load consumption in St. Martin Island. In case of every household, LED lights, fans, TVs are significant electric loads. The average capacity of LED light, fan, and TV is 30 watt, and the value of average electricity usage is 3.43 kilowatt-hour per day. From the table number 2, we can see the commercially available electric load consumption in case of shops in the island. Approximately 170 shops are located in the island. Majority of the shop owners are local. The amount of average usage indicates 1.6 kilowatt-hour per day. Table number 3 indicates the electric load consumption of a community clinic situated in the island. Actually, the critical patients who require unique kind of treatment are referred to the better equipped hospitals located at Tekna. The main elements which are responsible for electricity demand in this clinic are LED lights, fans, microscope, radio, and vaccine freezers. The amount of average electricity load consumption is 56.52 kilowatt-hour per day. St. Martin Island is a popular tourist spot, as I already talked about. Majority of the tourists travel to this island from November to March. Around 2,000 to 3,000 inhabitants of this island are temporary businessmen, and they gather during the tourist season in this island. There are around 15 hotels or resorts, and each hotel has approximately 20 rooms. Table 5 indicates the electric load consumption for a single room of a resort, and the average electricity consumption is 1.12 kilowatt-hour per day. While figure number 6 indicates the daily domestic load variation. In this slide, the PV system consisting of wind turbine, solar PV, converters, and batteries is presented. In system 1, generic flat plate PV satisfies the demand. The generic flat plate PV actually satisfies 18.95% of the demand, and wind turbine provides 81.05% of the total demand. The power of wind turbine and PV arrays are transferred to the load through the converter. In this system, battery is used to compensate for the system power load deficiency and to improve the system reliability. Figure 6 shows the Homer input data for energy sources. Figure 7 shows the Homer schematic diagram for system 1. Figure 8, 9, 10, and table number 7 are related to the battery used in this configuration. Total 392 batteries are connected. 48 volt is the numerical value of the bus voltage. Energy throughput is actually the total amount of energy a battery is expected to store and deliver over its lifetime. The expected lifetime of the battery is 12.2 years. Feasibility study of system number 2 consisting of wind turbine, solar PV, diesel generator, converters, and batteries is shown in schematic diagram of figure 11. System components are diesel generator, generic flat plate PV, wind turbine, and converters. Figure 13 shows the fuel consumption of diesel generator for system 2. The converter consists of inverter and rectifier. Inverter lifetime is 15 years. And the efficiency is around 95%. Capacity factor is actually the ratio of the average power generated and the rated peak power, and the capacity factor of wind turbine results in 13.1%. In this slide, the cost analysis of the two systems is presented. Table 10 and 11 provides the cost summary respectively. For system 1, the cost of energy is 46.25 BDT per kilowatt hour, whereas the cost of energy for system 2 consisting of hybrid energy sources is 38.07 BDT per kilowatt hour. So we can see there is a significant reduction of cost in case of system 2, which is a hybrid energy system. I'm going for the conclusion now. As we know, the quality of life of the people depends immensely on the availability of electricity. This paper depicts a study and comparative analysis on designing off-grid and hybrid power systems for remotely located island like Saint Martins. For system 1, solar PV and wind turbine are regarded as the renewable energy components. On the other hand, for system 2, the energy sources are diesel generator, solar PV, wind turbine. After collecting data from different sources, a software named Kumar is used for simulation to ensure cost-effective and reliable supply of electricity for Saint Martin's Island. The sensitivity analysis is also performed because there are some variable parameters like the cost of the fuel, the solar radiation, the wind speed, as well as the cost of different components. The proposed hybrid system 2, which consists of diesel generator, solar PV, wind turbine converters, and battery banks, can produce electricity at the cost of 38.07 per unit, whereas the residents of this particular island are paying much more price for per unit electricity. Besides, without diesel generator, per unit cost becomes BDT 46.25. So, at last, we can say the proposed hybrid energy system, which is system 2, and that is consisting of wind turbine, diesel generator, solar PV, can provide a reliable electricity supply at comparatively lower cost to the inhabitants of this offshore remote island like Saint Martin. The feasibility study for applying the proposed model in similar places in the world can also be studied in future. These are the references used for this. These are some references in this paper. I would like to thank all the panelists for your patient hearing and provide me an opportunity to present my work in this conference. Thank you.
That's a very nice presentation. I remember reading your paper in detail for the conference, so thank you for presenting it and doing a very practical analysis. I don't have any questions. I'm sure Ashok may have some questions for you.
Your cost of electricity is LCOE?
Yes, sir. LCOE. Yes, sir. Levelized cost of electricity.
Okay. And when you said that current rate of electricity is how much?
Current rate of electricity for the off-grid system is approximately at this moment around 50 taka.
No, but what are you saying off-grid means? How is that running? It's just solar?
By the diesel generator mainly. Actually, recently 250 kilowatt solar panel has been installed, but previously the major energy source was actually diesel generator, and that used to
okay, that's fine. That's fine. So diesel generator is good. You have assumed a very large battery life. I mean, how would you get 12 years of battery life?
Sir, we are actually using Suret. We are actually using Suret 6CS25P battery. So this is actually a battery which can be recharged after the 40% decrease of the charging, and that is how we are trying to increase the lifetime of the battery. This battery can also be replaced after 5 years and has 1156 ampere hour rating. So I have used this particular Suret 6CS25P flooded lead acid battery for this particular simulation.
That is very interesting, and I'd like to know more about it because that is one of the key problems everywhere we face.
Correct.
And inverter, 15 years means which inverter?
Sir, inverter.
Practical.
Yes, sir. The inverter actually we are using. We are actually using the inverter lifetime is approximately we are using 15 years. But if the inverter is actually not being able to cover that particular time, we are approximately having a maintenance operation cost for that. So if that fails before that, we have the operation and maintenance cost to replace that particular inverter. So that cost is also calculated here, and after considering that cost, the levelized cost of electricity is coming. So actually, in case of okay, thank you, sir.
Yeah, I would like to read more about it, and do get in touch with me. We would like to see how we can use some of your research.
Thank you so much, sir. Thank you so much.
Thank you, sir. So that was the end of all the papers. So over to Narayanan sir for the end note, and after that we will have a small photo session and we will end the session.
Everyone, for a range of papers, a number of them are around water purification and management using tech, especially as applied to rural or village settings as much as possible. And then around hybrid PV systems with wind systems like, island or Jaggery units and so on. And I think we had a paper on analysis for climate change for long wavelength radiation. So interesting area of papers would continue, would encourage, some of you to really continue in depth further. So, yeah, so I didn't have anything else. Ashok, any comments from your end?
No, I think interesting papers, and I was encouraged to see so many efforts on the water side.
Yeah.
And that is one area which is, climate adaptation is becoming more important than your mitigation side. A lot of work in mitigation, but we need to focus a lot more on adaptation.
Yeah.
And I'm really happy to see that. And I'd like to speak to all the guys who have presented on water, because we are working extensively in water, and would like to get in touch with all of them.
Sure. Thank you. Back to you, Advait. Yep.
Thank you, sir. So I request everyone to turn on the video so that we can have a photo and the session.
Advait himself is not on the video.
That's okay. Yeah.
Okay.
Yeah. Thank you all. So that's the end of the session. So see you all in the afternoon. Thank you.
Okay. Thank you.
Thank you.
Puneet sir, I have made you the host.
Yeah, Advait. I think that should be fine.
Yeah, thank you, Advait. Yeah, so that should be fine.
Thank you, sir. Thank you.
All right. Chengappa, can you give me the permission to project this slide?
Sure.
Okay, fine. Let me project. You are able to see, right? I will make it maximized.
Okay.
You are able to see, right?
Yes.
Yes, yeah. We see in the full screen mode as well.
Yeah. We can start exactly at 2 o'clock. So I'll straight away start, or anybody is going to be there? Puneet is there in this session, or Chengappa?
Yeah, I'm there. I will give 2 minutes of introduction and then you can start.
Sure. Thank you. I was just checking out that.
Yeah. Chengappa, I think recording is going on. It is not showing. It is showing only stop recording.
Yeah. No, I was checking for the previous session when we ended, right? So we had to pause it. So no worries. Let us continue, and anyway we can edit the file later.
Okay. So it was continuously going on, huh?
Yeah, that's true.
Okay. So let people know that there was a break. No problem.
Okay.
Okay, I think already we are 2 now. We will start. Yeah. So good afternoon, friends. So after morning sessions of plenary as well as breakaway sessions, we are again assembled here after lunch. And we are going to have very, very wonderful and exciting presentation on IEEE HSC grant proposal. And this proposal is really important for the faculty as well as the student members, because whenever I will talk to any IEEE student branch counselor or any academic professional or even principal, HODs, deans, everybody is looking for funding opportunity from IEEE, because these days what they are telling, sir, if I will get any funded project, my grading, my college grading is going to improve. I was surprised to know even this 5,000 rupees project also made them so happy, which we initiated at Bangalore Section, that is IEEE Bangalore Student Humanitarian Technology project. They wanted a certificate as well as letter of allotment that this project is allotted to them. So you can see that when an minuscule amount of 5,000 can make such an impact, then IEEE HSC projects, which starts from $1,000 and goes as high as $60,000. In Indian rupee, it is 45 lakh rupees. It means really you can do something meaningful. We are in this conference from the day one, we are talking about sustainable smart villages, sustainable cities, climate change. Whatever we have discussed, we all can do and implement with that amount of money what is going to be given by IEEE, and that too from IEEE HSC. what we understand from various committee members, I think Dr. Jayakrishnan will be talking in detail, that IEEE has more money than the good project proposals. If they get good project proposals, there is no dearth of funding opportunities. So we at Bangalore section thought that let us have one dedicated session on how to write a good project proposal or a winning project proposal for IEEE HSE. And Dr. Jayakrishnan was kind enough to agree, and he has agreed that he will be taking entire 90 minutes of workshop on this, how to write a good project proposal, and he will be providing his insights as well as some of the key parameters which the evaluators at IEEE HSE are looking forward, which should be in your project proposal. I hope after this workshop, each one of you will be able to write a winning project proposal and getting funding for the idea which sometimes I have heard they are having ideas from last 3 to 5 years, but they are not able to implement it because of they don't have proper funding, or they have applied funding to various other agencies but they could not get it. The most important thing IEEE HSE looks that your project should be aligned for humanitarian activities as well as for the betterment of humanity. I request all of you to please utilize this wonderful opportunity what we have brought for you and learn as much as possible and try to clear any doubts if you are having. I am seeing interactions are very less in this last 3 days. I request all of you, please ask as many questions as you like, and Dr. Jayakrishnan is very, very kind enough. In fact, he himself will be asking you question and giving you the answer. So please utilize this opportunity and try to get benefited. Thank you very much. With this, I will hand over the stage to Dr. Jayakrishnan. Over to you, sir.
Yeah, thank you, Puneet. It is wonderful to be, again on a session here. When we submitted the proposal to IEEE Hack, they wanted, a session to be done like this, apart from, their chairs talking at, various sessions. So I have 90 minutes. Puneet has given me 90 minutes. So what I thought is, the first 1 hour, I will take you through this journey, through this presentation. And the last 30 minutes, I have asked a core product designer who spoke in the medical devices section yesterday to be available to, because he also has seen, what's happening in the academia, how the projects are done, what are the challenges, students, what are the typical mistakes students make. So he is going to, talk about some of the best practices that students can use, and students can also throw a lot of questions to him because he is a veteran of almost 30 years. He has worked in GE, he has worked in DRDO, and he has owned his own design and manufacturing organization currently. So he is the best person who has both hardware and embedded software expertise. And I will also take questions on other types of software, especially the enterprise type of software. And I have my colleague Narayan here. He is also a very strong software techie, especially in the networking and cloud and all those areas. So together we are going to clarify many of your things. So let me do a 45 minutes to 50 minutes talk, and then I will get Mr. Balamurli on the panel, and then we can have an interactive session. So we are going live on Facebook here. So I know many of you, the friends are on Facebook at this point. So you can ask questions in the Facebook chat, Facebook comment section, and our colleagues will pick up the questions from there, and then they will maybe Neha, if you can help pulling some of the questions and ask, that'd be great, because while I am on a full screen mode on my presentation, I am not able to see other things on my computer. I don't have another monitor here, so I need some help from you. So any time, I think suppose I get dropped off or something, Neha and Chengappa, you can give me a call, so that otherwise I won't know, because I'm not watching the other things. So this is a presentation which I did, say on 5th of September, on the day of Teachers' Day, one of the universities in Kerala called me, the VC called me and told, why don't you do a generic session for all the colleges? There were around 140 colleges under the university. And so she told, why don't you give a generic presentation? Because that was 10 days before the COVID call of proposals of IEEE. So I thought, it would be a good thing, if we speak in a generic forum like that, instead of talking to any particular college, then there won't be fairness. So I talked to an audience of almost 140 colleges, their faculty and students through this university. So that's a presentation. So I may skip some of the sections in this presentation. So that's the thing. So this is the agenda. So I'm going to give a quick overview. I think maybe some of the people here may not be IEEE members, and they may want to become IEEE members as part of some of this project discussion. So to that extent, I may just touch upon a couple of minutes on an IEEE and its humanitarian activity. Then I'll explain what are all the typical funding opportunities from IEEE. Then I will talk about the project proposal development, which I will bring up a template at the end, and then we can go through the various sections in the template. But in the next 45 minutes, while I'm going through the slide, there itself I'll be touching up the various sections, but in a cohesive fashion. When I bring up the template, you'll be very familiar how to complete those things. I will just quickly give a touch a minute on United Nations Sustainable Development Goal, and I'm going to talk about some 3 case studies which will give you a good perspective on how to make projects and things like that. And I will also explain what are the key project attributes and best practices in these projects. Then I also will touch upon how do you execute project once you receive a funding. And then at the end, how do you do an impact assessment? That's what I do. And I will conclude, maybe at the end of some 2:50 or, around 3 o'clock. And then I will get the panelists and we can have a Q&A. So that's the agenda. Okay. I think certainly what happened, I think they're sharing a preview. I think my slides were moving. So IEEE Hack, all of you know, it is a team of people in IEEE, basically working on humanitarian activities. And this committee, reports to the board of directors of IEEE. And currently, Karthik Kulkarni, one of the prestigious members from Bangalore, he is the IEEE, Hack chair. He is based in California. So under IEEE Hack comes IEEE Site. How does SITE expand? SITE is nothing but special interest for humanitarian technology. At this point, there are 140 or 50 site groups across the world, and there are around 10,000 volunteers attached to the site groups. These volunteers could be IEEE members and non-IEEE members, and it need not be attached to a particular organization. Multiple colleges could together make a site group. So there are a lot of flexibilities given in site group. As I told, no need for everybody to be an IEEE member. There could be non-IEEE members also, and multiple colleges and institutions could collaborate to make a site group, 140, 150. So at this point, site is led by, again, another a very active volunteer called Sampath Veeraraghavan. He is from the IEEE Chennai section. Sampath, very active volunteers in site in the starting from around 2000. It was in 2000 that this whole concept started. It was in fact based on a work from Trivandrum. There is a gentleman called Amarnath Raja. He is a very senior IEEE person, and he was a global leader of IBM. So it's 2005. There was a tsunami in the Bengal coast, and he and his team from CDAC in Trivandrum, they went to the place and they set up a communication network. Basically to support the responders in that area. So then when he came back to his state capital Trivandrum, he wrote to the IEEE board of directors and their IEEE president that time, and they initiated this activity called IEEE Site and Hack. So I heard from our Karthik that he was the first IEEE Site chair in 2010. So Amarnath Raja is the pioneer in this wing of IEEE. This group is basically involved in executing projects across the world on different aspects of sustainable development goal. The mission of IEEE, as all of you know, is foster technological innovation and excellence for the benefit of humanity. So in that mission, IEEE Hack supports the IEEE board endorsed vision of IEEE volunteers around the world carrying out and or supporting impactful humanitarian activities on the local level. So that's the alignment with respect to the core IEEE mission. What IEEE Hack site teams do, they want to build awareness on humanitarian technologies across the OUs. OUs, as you know, it's a section could be an OU or a chapter could be an OU. Student branches could be an OU. So there are different entities IEEE, which is called an OU. So spreading awareness on all these humanitarian activities, that is one of the activity. And then they have also set up a lot of training sessions, especially sustainable development, what is it, and how do you develop human-centered projects, and then how do you do project assessment. So there in the IEEE learning network, there are at least some 6 good videos which have been created, which is used by volunteers across the world. The 10,000 plus volunteers I told on the site, they typically take these courses, and we also insist all the people who participate in this project to take these courses. Then there are project fundings which are going to happen every year. So I'll just touch upon these things. And then they also start partnering with other foundations across the world. So this year, the Karthik, I was working with him how to partner with Philips Foundation, where I had the opportunity to work for 2 years while I was part of Philips Innovation Campus. So he was following up on that. So there is a partnership lead in the IEEE Hack, basically looking at how IEEE as an organization, because IEEE also has got IEEE Foundation. So how do different foundations come together so that they have a common interest in communities? How do they collaborate and make things happen? So there is some work happening on collaborating with Philips, especially in the Africa and those areas. So these are the typical activities. And quickly, 1 or 2 minutes I'll spend on the funding. There are multiple schemes in IEEE, for funding humanitarian activity. One program is called IEEE EPIC. Our Professor Ramesh, who is going to talk in the evening, he is an active champion of IEEE EPIC initiatives. In fact, his team only signed an agreement with Purdue University, and US it's a major movement. And Mr. Ramesh also told that he has worked with almost 15 universities in India, basically to do this sort of work. Typically, this funding of $1,000 is used for assistive technologies, especially differently abled friends of ours, basically to build solutions for them. And there are other activities like community gardens, and then feeding the what you call homeless people in US. So there are multiple interesting activities this EPIC does. And then the next is IEEE site and IEEE Hack. So IEEE site, typically, the funding goes from $1,000 to $20,000. All the projects have to be aligned with respect to UN SDG 2030. And then IEEE Hack is the biggest body, which is reporting to the board of directors. IEEE site is a lower umbrella which reports to Hack intern. So Hack projects are typically large projects, $20,000 to $60,000, and Puneet already told almost 45 lakhs is the value of the funding that you get from there, especially for very impactful project. But this year in 2020, IEEE didn't give any site or Hack fundings because by the time the proposal call was done, Corona has taken over most of the different parts of the world. So it was decided by the board of directors and the IEEE Hack head Karthik, that why don't we just start funding these COVID response projects. So there are a variety of projects in the COVID response area. We will discuss that. So that means instead of funding large amounts for different few projects, they thought it will be good if $5,000 is funded for more number of projects. So if you look at the history of 2019, something like 10 to 12 projects were funded in Hack, and there were some around 20 projects were funded in site. That's how it was 2018. And but this year, that everything is the same amount, $5,000. Typically, the site and Hack projects are 12 months in duration. But then this time, since the funding is smaller and we need better, faster, action from volunteers and better faster outputs, the duration has been brought to 6 months. So $5,000 in 6 months. So there was a call for proposal in sometime in April timeframe, and around 120 projects, 120 or 110, I don't remember. Projects, the proposals were received, out of which 70 projects were awarded. So that's the first call, and there was another call which just concluded. That around 15th of September, the cutoff date was there, and again we received almost 114 projects from across the world, and then the team is almost finalizing the shortlisting, and within the next 1 or 2 weeks, the projects will be awarded to people. So already 70 projects are funded now, and maybe there could be a certain number of projects in this in the next 2 weeks. So totally more than 100 projects may come out from this one. So instead of 10, 12 hack projects and 20 projects in the site, that is 35 projects this year. Around 35 100 more than 100 groups are going to get funded with this $5,000. And as Puneet mentioned, even when we started this humanitarian this conference theme, it was thought we should encourage students to do projects, and that's how he was gracious enough to carve out a certain funding and award 5,000 rupees to all the participants, around 70 or so. And I had been part of a couple of the project discussions yesterday. I see a lot of interesting projects were done for this 5,000 rupees. So that's a great trigger. The 5,000 rupees is a great trigger. But then there are a lot of improvements we can do on the various projects. So that's what we are going to discuss from 3 to 3:30. Because all the learnings, all my observations, I just wanted to feel to a product designer, and we will hear his wisdom, how we can improve these things going forward. And IEEE Hack also funds the various events like ours, because it's a 3-day conference. In the normal case, they could fund up to $10,000, especially when you do the conference in a hotel, or a lot of travels and other things are involved, up to the tune of $10,000. So this time, because of the COVID, they were very clear that people will not travel, and most of the sessions are going to be virtual. So they limited the amount to $5,000. So we were also able to get a part of this $5,000. Because this year, their focus had been to distribute this money, for various projects and things like that. And it also allows, the individuals, in IEEE members to attend, international conferences on the global humanitarian technology area. In fact, October the end, around 25 or 28, there is a conference, happening in Seattle. So this time it is again going to be, virtual mode. So that's the flagship conference, global conference. But proudly, Puneet and all of us, can claim that our conference was much, inclusive and much more, rigor in all the discussions. So today, just in the afternoon, in the IEEE Hack site, I just put an update, showing the links to our conference and the deliberations which happened, and giving links to IEEE YouTube channel, so that the international audience, let them also go through our things. So that way this year we showed the path by having this conference on this 8th to 10th, and then the global conference is going to happen by the end of this month. So I think people are really looking forward to the deliberations what happened in our conference. So I given all the links in this social media page this afternoon. And another interesting activity is called IEEE Smart Village. Okay, that is basically this aims at providing sustainable energy solutions to areas like remote areas, because this is a very active movement, especially in the Africa. I had the opportunity to talk with a couple of practitioners of IEEE Smart Village. So they were thanking IEEE for the funding they received, because in Africa, some of the remote places, there is no electricity. So they were able to put PV panels. They were able to connect the various appliances in a home, and it also enabled them to distribute some of the solar lamps and things like that. So in Africa, it had made major impact. So from what I heard from the practitioners is that from $25,000 and very high amounts, IEEE funds for impactful project, using a renewable energy, trying to lit villages and things like that. But I didn't get the upper limit, so I just kept it as above. And then in the morning, there was a speaker who spoke on IEEE Move. It's a mobile outreach vehicle. It is a vehicle which goes to all these natural disaster places, and it helps the what you call Red Cross, because Red Cross they are all well trained in handling all these emergencies, especially during tsunami, then hurricanes and things like that. But what is missing in this Red Cross is that the technology rigor. That's what IEEE volunteers are going to bring. In the IEEE Move, I understand there are a lot of technicians who has worked in a lot of companies in the US. They're all part of this IEEE Move volunteers thing. So in fact, there's got a satellite dish on the top by which you can connect from places which doesn't have a connectivity, and it also has got a lot of equipments basically for charging all these what you call walkie-talkies, which typically these first responders use in all these disaster sites. So it has got a lot of inside things basically for communication, because both for satellite connectivity using the dish on the top, and all terrestrial communication mechanisms are there, and a lot of this power bank charging and all sort of infrastructure is there. So in one of the conversation, I think I remember the MOVE lead was talking in a Bangladesh IEEE conference. So I was there part of that conference. I was listening to that. So I just suggested to her, why don't you also augment this with some of the healthcare related first aid plus some of the basic telemedicine equipments inside this, so that you can connect the affected parties from a remote place to the best hospitals in the world, and so that doctors can quickly diagnose the issues and things like that. So she told definitely she is going to consider that idea. So Puneet also updated this morning that IEEE India is getting a similar vehicle for our India, and IEEE Bangalore Section is taking the lead in architecting how this vehicle need to be integrated with all these communication equipments and other things. So I am also suggesting to Puneet and team that do consider telemedicine equipments inside this van, because that's the best way to get many of the what you call suffering people in these disaster areas to be looked at by our specialists like our Ganapati Krishnan, who was there in the call. Interestingly, Ganapati Krishnan, after our talk, he told me, kindly pull me for any major projects, what is happening in your IEEE section. So Puneet, it's for you to connect with him, and he can definitely guide on telemedicine, especially around this platform that you are trying to build. We can discuss that in the end. So I think right. I think, this picture, all of you would have heard, because this is the theme of our conference in the last 2 days. So this is Sustainable Development Goal Wheel. In fact, UN, India site, there is this wheel. I have put a link at the bottom. So if you click on the link, you can come to a circle like this. And then if you click on each of the goal, there is exhaustive documentation which will pop up. So I encourage all students to go through this color wheel, which is part of United Nations India site, the link that I have provided at the bottom. So I will not talk much about these things, because the importance of United Nations Sustainable Goal is that this started in 2015, and the goal has to be achieved by 2030. So already 5 years passed and 10 more years to go. So I think if you what we call think about all these challenges, because these are the challenges which are keeping many of our lower strata of the people down, because if we look at the whole thing as a pyramid, the bottom of the pyramid, as they earn less than $1, and so the people, it's not that the 7.5 or 6 billion people in the world, everybody is rich. The half the population in the world, they are living in poverty and a lot of areas. So if we want to uplift them, we have to work on projects in each of these areas. So the last 2 days, we had deliberations, and we are continuing to have the deliberations. How engineers like us, can get involved in projects where we can uplift our downtrodden and economically lower strata society. So the last section in this one says SDGs could open up to 17 trillion of market opportunities and create 300 million new jobs by 2030. This is wrong. 2020 is not correct. 2030. So 17 trillion market opportunity and create 300 million jobs by 2030. So that's the ultimate goal. So that gets distributed across all the 17 goals. And if we keep working on these things, and India also, because 1.34 billion people are in India. So out of the 7.5 billion people in the world, a major portion of the people are in India. So United Nations is also looking very closely at how India is progressing, because India is going to be the role model for many other big countries. So COVID call proposal, in fact, $5,000 I told, 6 months. And there are three major areas, the funding is happening. The first is, immediate impact, where, this was the scheme, in the April funding. But in this recent September funding, they added two other line items called poverty mitigation and inequality reduction. So let me quickly touch upon the immediate, impact projects. So these are all typically medical devices, then infection control devices, then the personal protection equipment, community sensitizer and things like that, and ICT. So in fact, this year, I am the lead for the community of practice for medical devices. I handle almost 15 projects across the world. There are a couple of projects from South India, especially Kerala. I have some 3-4 projects which is handled by my colleague, because of conflict of interest. I told some of these projects need to move to another person to monitor and things like that. So I don't monitor anything in the South India aspect, because I am part of this region. But otherwise, I have around 15 projects from around the world. Most of the projects, 80% of the projects are ventilators. Different, people are making, ventilators and oxygen, what you call sources and things like that. A couple of groups are working on, unattended trolleys, basically, to go to, the bedside and pick up waste and various things. That is another type of project. And I see vital science monitoring projects are going on, and there are thermal, scanning projects are going on. So that's how, medical device category is coming up. Infection control is like, sanitizers and, various things like that. And PP, as you know, especially in Africa, and even Bangalore Section, have taken up a 3D printed, a PP project, which they should be completing now. Abhishek, Apaji is leading that team. And then there are large, ICT projects, especially, information portals and, mobile apps and things like that. Especially South Africa, there is a team working on, a visualization portal, for COVID and, all those areas. So that's the type of ICT. In fact, there are some 25 projects now in the ICT domain, and it is led by, one senior person, IEEE, a person from MIT. So we have started this community of practice concept this year, because it was this MIT person, it was her brainchild. But community of practice is nothing new. It is like special interest group, which had been there in all organizations in India. But then, when MIT gets involved, it will get some more color, like community of practice and things like that. So she has bringing some new concept of projects across the world collaborating. Because, for example, medical device, many people are working on ventilators. So the idea was basically all these projects to share their best practices. So since Karthik pulled me as the first thing, I did a lot of work in creating a collaborative platform, and then I encourage people to collaborate. But the ground line, when you look at the ground truth, I don't see much collaboration happening. So these are all some challenges which are there. But then as IEEE Hack, we did our best to create platforms, create communication channels for these project teams to collaborate, and then publicize what they are doing and things like that. But the adoption rate of these platforms are very poor, and there is a lot of what you call lethargy when it comes to people following some of the process, which I will highlight later. And then the next this year is poverty mitigation. That means COVID is not just some medical and those areas. Because of COVID, you saw migrant laborers walking roads miles and miles. So this poverty mitigation is one of the areas that they are looking at projects. Okay, because especially these migrant laborers, when they go to the village, they need to have a livelihood. So whether they can do some renewable energy based pumping systems and storage, all those things are addressed by poverty mitigation. And this funding, they added inequality reduction. Because as you know, schools have started from June, in many of the states in India, and then there is a digital divide which is really hampering the progress because people who could afford mobile phones and tablets and TVs, they are able to listen to all the educational content aired by the state education departments. But there are a lot of people who cannot afford all these things. But then many people stepped in and organizations stepped in and they donated TVs and phones and all those things. But still, there are a lot of people in the country and in every state who doesn't have a connectivity and things like that. So I saw some interesting projects from some regions of India where they propose they will bring up some Wi-Fi networks within their schools by which students can come not inside the classroom but outside they can access internet things like that. So only thing is we need to get a fiber optic connectivity for the nearest what you call point of presence and then connect to the school and then turn up illuminate a Wi-Fi network and students can access that. So these are all the projects and then clean water and those things. So all these things information is available in the hack site, IEEE hack site. There are two sites. One is IEEE hack and the other one is called IEEE site. So I encourage all of you to go there and go through extensive documentation is there and there are training videos are available and then all these things will really help you to just ramp up. So yeah. So let me take you through a couple of quick projects for you to understand the magnitude of the projects that IEEE volunteers across the world do. In fact, this is a project which is trumpeted in the IEEE hack site as one of the very impactful projects. So this is a project in South America. It's a place near to Ecuador. So Ecuador, from the Ecuador to the west, around 1,000 kilometers, there is a place called Galapagos Island. This is one of the most famous tourist destinations in the world because the natural beauty, which you can see on the top, that makes a lot of tourists to travel this place. And then, especially from India, a lot of amateur divers go to this place because it's a divers paradise. That's what I understand. So it's a very tourism, it's a high potential tourism place. But what is happening in the last couple of decades, they started seeing a degradation in the biodiversity, in this area because there are not much forests here, but then there is a lot of special species of plants and special species of marine artifacts and all those things. So because of this inrush of tourists, it has started suffering. So a team of IEEE volunteers has come together to bring in awareness programs to students, faculty, and even the community members. In fact, when I was talking to a project lead of this project, he was saying 34,000 people are there across some 11 islands in this place. So last year, they picked up a place called I forgot that particular island. And this year, the island is Santa Cruz. So the last year's island, San Cristobal. San Cristobal, there was 5 schools were there. So they connected the schools using fiber optic cable, and then they turned up Wi-Fi access points in each of the schools. So the biggest challenge this community is facing is since it is away from the mainland, satellite connectivity is the only way by which they can get into the internet. But what's happening is satellite connectivity is very slow speed and it's very expensive. Unlike our country where the charges are rock bottom, all these South American countries it's very expensive, even every kilobyte of data. So there is an OC3B satellite connectivity which is pretty slow, and so what they thought is they will do a local intranet where they will use the content delivery network concept where the educational content they will locally cache, and once they locally cache in their servers, they should be able to distribute that to various stakeholders in the school, like students and teachers and things like that. So this team, apart from building a telecommunication network, they also built this cache content cache servers, and they also created some of the software basically to make these contents. So it's not only just telecom network. They also have got a application development infrastructure and content ingestion and infrastructure. So all these things they implemented. But interesting thing in this project is this island doesn't have universities. It's all secondary and higher secondary students there. So the mainland has got a university, YESPOL, and the one of the professors from that university is the project lead of this. So I had this opportunity to talk with him. His name is Caesar, and he also is supported by a professor from Villanova University in Philadelphia. His name is Prithpal Singh, and he is one of the leads, in the site, committee. So last week, 2 weeks back, I had 1 hour interaction with them with respect to some of the technical aspects of this project, because I had some concerns in the way in which they are trying to deploy some solutions. Because as you know, in this sort of an internet environment, you will have tablets and mobile phones by which students can access the content, and the contents are typically placed in a server. So when we talk about server, this team has used a cluster of Raspberry Pi boards basically for making these server cluster. So when I initially read about this project some 3-4 months back, immediately I felt there is some disconnect here, because Raspberry Pi is used in embedded systems and gateways and other things, and it's not that reliable, we can say. But when so in the universities, in Villanova and Ascol and all, they are able to integrate all these things, and there are very experienced researchers who can debug the problem. Suppose a Raspberry Pi doesn't work properly, they can debug what is happening and things like that. But when you give it all the solution to a community, a remote community like this, suppose even if a small fuse or a wire got cut, they will not be able to use this particular system. So $60,000 IEEE hack is given, and then just because of a small failure somewhere, if the whole system cannot be used, it is not a very good thing. So I was basically telling them that, especially because most of these projects I am seeing a lot of academic professors getting involved. So my suggestion to this whole committee is that whenever we give large projects like this, involve some industry people also, because industry people will ask so many questions, and that can really help these people to come out with some good solutions. So when I talked to the professor, he also admitted that there is some reliability problem on Raspberry Pis. Some of the Raspberry Pis are just getting getting charged because of some temperature and all those things, and the reliability is poor. So they started realizing the challenges, what is happening on building large projects like this based on some of the open source hardware, which is not really tuned for a highly reliable operation. So what the last report I heard from this team is that they are working with respect to the local ISP, who is going to give some space from his commercial off-the-shelf servers. So at least they acknowledge that, saying that the schemes that they did, they also made a couple of papers and they published in the Global Humanitarian Technology Conference. I read through these papers, but then what is happening is everything is fine. When you publish a paper, you can build things in your university, and things may work. But then when you give it to a remote community where the environmental conditions are different, the people who are going to use this are different, then all these practical challenges will come up. Raspberry Pi is not a solution for those sort of environment. There we need reliable off-the-shelf server hardware which has got a good reliability, so that we will not get into all these problems. So they appreciate that, and they understand that. So at the end of the discussion, we told every large project there should be a couple of industry members who will bring that rigor of practical deployment and other things to these projects. So this project, though it is basically to do a networking, basically to provide content to students and other things, the ultimate aim is basically to build awareness among the students and all those people, their parents and all those people, to take nature with handle nature with extreme care. Because biodiversity, as I told, it's a rich biodiversity place. It's a fragile environment. So in the name of tourism, you cannot manipulate all these places. So building awareness through an intranet, that is the ultimate thing. How do you achieve that? Through education. So SDG 4 is there here, and there are, you can see multiple SDGs they are addressing. Though this is the case study of this project is available in the hack site. There is extensive documentation on this. But then all these things in a website looks beautiful, but when you get into details and when you talk about the reliability of these things, there are challenges. So let us learn from these challenges and build impactful projects from our country too. The next is a project happening from Argentina. This is on the it's going to be done. It's done, I think, this project, but then there is a delay because of COVID. It addresses multiple SDGs here. So basically, what they're trying to do is they want to lift the groundwater from below using a what you call pumping system with which has got a renewable energy powered pumping system. So you can see the team here, and they are doing some trials in the Buenos Aires and those areas. But this will finally move to the southern part of the Argentina. We have also learned about this part of Argentina called Patagonian steppe. So it's an arid land where the groundwaters are pretty low. So they want to pull water from ground using this renewable energy based water pump, and then use it for drinking and at the same time for irrigation. So that's his project. So I didn't have time. I didn't have the opportunity to interact with this team. So I don't want to take much time to explain this. So this also you can see in the IEEE hack site. You can see who are all the stakeholders and things like that. This is the last project. Now I had some extensive interaction in the last 3-4 months. This is from a place in Bolivia. Bolivia also, as you know, is a South American country. So here, instead of a community intranet, basically for education, these people are trying to build a communication network for basically for healthcare purposes. That means there is a a main hospital, and there are other remote healthcare posts similar to primary health centers in our villages. So currently there is no communication, and in this region there are some internet service providers operating, but the charges are prohibitive, at least 20-30 times our rates in India. So this team decided to connect these different healthcare posts using a high-speed wideband radio. And finally, once wide area networking happens, every healthcare post in hospital, there will be Wi-Fi mesh routing systems, which will open up radios for local community people to access. And I say community, doctors could access, then the nurses could access in this hospital, and a couple of entrepreneurs. All these places, there are entrepreneurs who take lead and various things. So IEEE, what they are trying to do is they connect with the entrepreneurs, they connect with the community key members, and in this area there is a school where there are some technical folks available there, because all these IEEE projects, though it is funded for 12 months, IEEE wants to see that these projects sustain. Because IEEE gets out of these projects after 12 months, but then it has spent $60,000, and if it is not maintained, then all this money will go in the drain. So what they expect is the local community or some members, they should come up. So in this case, the entrepreneurs in the local place, they are going to come up, and then the technical school is going to come up, and they will take this project forward. So this project also is currently getting into big mess now. Because this is around a lake in Bolivia called Titicaca. I think all of us, as part of geography, we have learned about Titicaca. It's a saltwater lake, at a certain height, from the plains. So it's a windy place. So these people are trying to erect, the towers, and then for this high speed, broadband radio. So they are encountering a lot of challenges, because this is not only electronics and all those things. There are a lot of civil works, basically for constructing towers. And these are all rocky terrains, and so building those things, they are using the services of some subcontractors. So there are project management challenges here. So in these projects, these large projects, one of the major challenges I have seen is project management challenges, because many of the people involved in these projects, they're all from the academia and students and things like that. Again, I'm telling, unless industry folks are pulled in these projects, you won't be able to understand the challenges which will happen, and then it will derail projects and things like that. But one interesting thing I saw in all the South American projects is that most of the project leads, they did their higher education from US or Canada, and they came back to their native places, and they're working with the communities to build these projects. But very ambitious project. So now I am coming to the IEEE, proposal development. So this year, the projects are more or less, the call for proposals have been over. Next year, sometime by, February, March, the next call will come. These call for proposals typically happen, twice or thrice, in a year. In this year, it happened only twice, but in the normal 2018, 2019, and all, it happened 3 times. So what they typically want is, in all these projects, IEEE wants, the local team. Okay, when I say a team, it can be IEEE members, non-IEEE members, and community people and things like that. So there are certain criteria. The criteria is the sense that we need to partner with a local NGO or a governmental agency, because IEEE members, they are good in the labs and colleges and things like that. But when it comes to community connect, we are not that good. Okay, and because there are a lot of cultural issues and a lot of local issues which many times some of us don't understand. And as engineers, we have a major gap now when it comes to understanding the mind of the people. So there are social scientists, and then people from psychology field. Then all those people are there in the community. So you need to partner with those people. Okay, and then you need to start working with the community to understand what is the actual challenge they are facing. What is the actual problem? Okay, so you have to do extensive surveys and things like that, and then you will get multiple insights from these places, and then you have to pick up the top few insights, and then you have to work on a solution to that problem. So I am not taking that aspect because I have done a couple of sessions, one for IEEE Bangalore Section, and then subsequently for the global community on human-centered design. So this is a technique which is from Stanford Design School and well practiced by companies around the world now. It's a 5-step process where you empathize with the local communities and then try to get as much insights as possible, and then you prioritize the insights and make a problem. So that's the second stage. So define a problem, and once you define a problem, then you go into the ideation stage where there are multiple solutions which can come up. And using some rating system, you can prioritize which is the best solution, and then you can start prototyping some of the solutions, and then start giving the prototypes early to your end users, and then understand how they are behaving with this solution. So I've got a slide later which I'll talk to you. So once you have identified a good need, working with these community people, then you are right, there to apply for a what you call site or hack funding. Because you have a problem in hand and you have got an idea about an approximate solution, now you can what you call start getting into the IEEE project proposaling. So when you do a project, what is happening? Every project you may need multiple inputs. So one of the input is labor. That is the people need to work, and then only projects will bring out things. So in the case of IEEE volunteers, they work for free. So it's assumed that in these projects, there is no labor cost. All those time that you as experts and as volunteers spend, it's free. That's why IEEE is funding these things. But then there are a lot of materials and equipments you need to purchase. That's all going to be funded by IEEE. So you need to find out how much you need from IEEE and how much you will get from your local university and other local agencies and things like that. So material plus people means all volunteers, and then a schedule, and then you come out with a schedule. Within 12 months you have to complete this project. So you keep writing down all the activities needed to complete the project, and the activities you may have to arrange in serial, parallel, and all those things which I'll show you later. And activities will result in outputs. Outputs are nothing but tangible things which will come out at the end of each section of your activities. For example, if it's a renewable project, solar panels we are going to purchase, and suppose the team decided to build an inverter. So they will buy electronic components, they will build PCBs, they will assemble, and then they will test it out. And then when everything is finally meeting the specification, we can say an inverter as an output. So there will be multiple outputs which can be in a project. These are all tangible things. And then what will happen is once all the outputs are available and you integrate all these things together, and then only the real benefit or service will happen. So in the case of Galapagos project, they bought a lot of networking equipment, the fiber optic, this thing. So all those things we can say they're all outputs. But then once you connect all these things together, and when the first child starts what you call reading the content, which is lighted by all these networks. That is the time we can say it's a outcome. Outcome means what did it result? All the spending what we did, if it has improved the awareness, global awareness of every child there, and then for what? That is the thing which I told for environment sustainability. If that person gets educated and if that person handles an environment with the facility which is part of that, and that's when we can say an outcome has been achieved. So outcome is nothing but a series of impacts we have made in the community, which is short term, And then if it lasts for many years, then we will say an impact. So the long-term effect of what you have done within 5 to 8 years, that is called an impact. So IEEE funded projects, as you know, within 12 months, it will all be over. And then IEEE comes out, but then in the next couple of years, outcomes need to be measured. And then in the next following, 4 to 8 years, you have to measure the impacts. So these are all things, which is a continuing process. But IEEE in the 12 months, they will look at whether have you achieved the outputs, have you achieved the outcome at the first stage. But outcome, as I told, it will span multiple years. So subsequently, it is for the community to screen these things. So this picture you should all keep it in mind. That means if you put it as a project as a black box, there will be inputs like your time, your volunteers' time. You decide how many volunteers you have to put. This could be IEEE, non-IEEE. There could be other community members. All those things together, you put it as an input there, their free time, and then you put all the materials and equipments needed for that. And then IEEE also gives you a small fund, basically to pay for some services which you are not having an expertise. For example, in your project, there is some welding which needs to be done. There is some soldering which needs to be done, or some critical work which needs to be done. For that, you can pay the local artisan or whoever is doing it, and then but then that cost has to be a small percentage of the overall budget. So that's also possible. But then you cannot employ a project manager or a subject matter expert consultant and start paying them. So that is not allowed. Because the thinking is IEEE as a community has got a subject matter experts, project managers, and so this is one of the ways by which the expertise of the local volunteers can be improved. So that is one thing. And second thing is through these projects, IEEE also expects many of the non-IEEE members looking at what the value these projects will bring to their resume. For example, I have seen in my community of practice, many of the people project teams have started publishing in the Spectrum magazine their work. So that is being read by an international audience. So they get instant fame. They get many times newspaper coverage in the local communities. So with all these things, these non-IEEE volunteers, they will think, oh, IEEE is a great organization we should be part of. And I have seen many volunteers joining IEEE because it brings benefits to them. So this is one of the metrics I am tracking as part of our community project. How many non-IEEE members have become IEEE because of this funding and improvement in their skill set and things like that. So I'm going a little slow now, but I'm just skipping some of these things. These 5 stages now is the design thinking stuff, which you should all use in all the projects. And there is a link to a IEEE hack session globally done, and at the same time IEEE Bangalore Section has done a session. So I will send some of these links to you for you all the student teams to go through. So these key attributes people should focus is these are also outlined in the hack site. But one caution I want to give, especially the COVID projects. Suppose in the next year, first half also, they are going to fund a COVID project. We need to understand one thing. Many of the project teams who propose these projects, they don't have much background in the what you call medical field. So it's a very regulatory industry. You heard a lot of people talking yesterday about how critical it is to develop products for the this medical field. So the last statement says medical device manufacturing deployment are highly regulated fields and require partnerships and approval by relevant national, federal, state or local authorities. So you should understand that these projects, especially healthcare projects, when it has got an impact of a human being, then you have to be very careful. But other projects like monitoring projects and things like that doesn't have that much critical complexity. So what as part of the COP we have developed a FAQ, frequently asked question, which has enabled a lot of project teams across the world to understand what are the areas that you should focus and things like that. So mostly we will soon publish this FAQ to the public, especially in the hack site. So keep watching the hack site. You will see an FAQ which is getting developed in the last 3 months. We had a lot of learnings across the world, and everything I'm trying to codify. I'm also trying to pull inputs from the industry folks in the medical device sector. So all these things together, this community practice is improving the standards of the project teams and things like that. The project's not considered a research project from the academia is not considered. We need to have applied research project, and it should have been done based on a problem identified from the community. So if it is just a research paper, this is not funded by IEEE at all. So need to be very careful. and only these areas which I discussed earlier, they are the only thing which will get funded by this. And this year, and there are most of the IEEE projects, they publish their outputs in the form of open source material, because if it is going to be used for commercial purposes, then IEEE doesn't want to fund a project where somebody is going to make money. So they don't fund pure research project. They don't fund a commercial project. The outputs and all those things if it comes onto the open domain, then there could be a lot of social entrepreneurs who can pick it up and scale for the world. So that's the purpose of these projects. And as I told, it should address a local need. So that's why design thinking is important, because we need to work with local communities, okay, through NGOs and then governmental agencies and things like that. So a lot of time has to be spent in the problem definition. Which is different, in the case of academic projects. Academic projects, everybody jumps into the solution without even thinking about what is the problem. So many times they are trying to solve a problem which is not there. Okay? So understanding solution of problems are very important. That's what the discussion in my talk on human-centered design, which is already there in ACT and IEEE Bangalore Section sites. And this time, they implemented a project assessment matrix. I'll just tell what is that. So project execution, I just wanted to tell you, because one of the major things I'm seeing around the world is, as I told, majority of the people are from the academia, so they don't follow any standard project management principles. So if an industry member is there, he is used to all these things, and he will bring the rigor to that. For example, in this committee, I just wrote what you call detailed project reporting template based on standard project management philosophy. And I saw a lot of resistance, especially from the projects where academia and those professors were involved. But I told unless you identify the risk in your project, unless you execute the project in a sequence, parallel, serial, and all those things, these projects are going to be a disaster. Which I can see in the last 2-3 years. That's what is happening. Some of the projects are getting delayed. Some of the projects are not meeting the outputs and outcomes in the desired time frame. All these things are happening because there is no project management rigor. Because many of the academia people, when they talk, they'll say, why academia should be bothered about project management. So if your intent is solely to publish research purpose, that's fine. But if IEEE hacks, projects, if you want to execute, you need to bring in some project management rigor in these projects. But believe me, these project management, things are not rocket science. Even a school student will be able to learn this if he takes a couple of videos in YouTube and things like that. So it has got multiple stages: initiation, planning, execution, and closing. Then you have to continuously track the project. So that's the controlling phase, which happens parallel to execution. So this is the IPEC, what you call philosophy by Project Management Institute, from where many of us got PMP certification many decades back. So I think all these things are well talked about in the internet, in various videos and things like that. So I encourage even students, because as I told, even school students, they will be able to practice these things if they take a couple of things. This is my last slide before we switch to the panel discussion. So I just wanted to spend a couple of minutes on this project assessment matrix. So as I told, outputs and outcomes are very important for any IEEE project, hack project. And on the top, there is something called objective. Objective means we need to, in a crisp manner, you should indicate what does this project, how these aspect has to be, in the objective. That means you wanted to improve the healthcare, of a particular village, and then you also say how, by setting up, a wideband radio network, with local, what you call Wi-Fi access points. So that's the how part. But what are you trying to achieve? Either you want to raise the education, literacy in that place, or you want to improve the, healthcare in that particular place. So that is the what aspect. So you need to write down, the objective very clearly here. And then, as I told, while you are moving through this 12 months period, many intermediate stages, you will get many outputs coming out. In the renewable energy project, you are making an inverter. I told, at the end of 3-4 months of your hardware design, and then making a board and then making it work, and then you say, the first output is ready. That is the inverter. But then, for us to get a total solution, you may have to integrate all these things. And then, when people start, getting the benefit of electricity for their appliance and other things, that is the time, when the outcome happens. But even when electricity comes, that is not a real outcome. Because of electricity, what happened to that village? What happens to the community? whether the education of the children went up because they were able to read in the night. And then maybe the farmer was able to store their food grains, perishable things in a cold storage. Okay, that's another outcome. So like that, what is the end thing which you achieve? But then there are intermediate things which are only just enablers. For example, electricity is an enabler from a renewable energy system, but that's not an outcome. Outcome is basically because of this electricity, how the living standard of the community is improved. That is what we need to express. So there are multiple outputs which are physical acts. I told, which is that's what I told. Outcomes are whatever I told. Where education improved, then the health of the people improved, like that you have said. So this time, this vertical columns are basically what is the indicator now for each of these outcomes, and then how it is calculated. So then we need to write, and then what is the current baseline without IEEE project? What is the baseline at which it is standing? For example, the infant mortality in a particular village. Currently, this could be this many number per 1,000. Okay, but after implementing in our project, what is the target? What is the target value which we want to achieve? From 100, we are going to reduce to 50. So that's what we have to say. And then actual means while the project is in execution, whether it has become 75 or 60, so that we need to say. And then data source, how it is measured, because many of these measurements, especially in the healthcare and other things, will be done by the local regulatory or hospital authorities. So who is the person responsible for measuring these things? So in many of the healthcare projects, you can see these ASHA workers, because ASHA workers are the people who go to every home and collect all these statistics. So maybe you can write, ASHA workers will do that. And how frequent, whether it's every weekly or whether monthly, this data collection is done. And then responsible. So who is responsible? Maybe, a lead of, the ASHA workers. You can give the person's name. And then reporting, because once you collect the data, it has to be reported to minimum HSE committee, because HSE, needs, every 4 weeks, one report. So that is one thing. And then you may want to report some of these things to your local, what you call, healthcare agency, district medical officers, and, if it is an educational project, it could be district education officer. Or in the case of primary, schools, it could be assistant educational officer within that taluk. So there are, people who are responsible to monitor, the outcome of, various projects, we execute in all these regions, whether it could be a village, whether it could be a semi-urban, or whether it could be an urban area. So this sort of a picture, if it is not there, the IEEE hack feels that these projects are they have not thought about that. So this time they are very, very strict on reviewing all these outputs and outcomes, and then all these vertical columns. So that's the thing. So at this point I'm just stopping, and I think I took almost 5 minutes more, and I will invite Mr. Balamurali to be on the panel here, and then we can deliberate on a couple of things with respect to the projects and things like that. Okay. So I think yeah, let me. I think what happened. So Sneha, I think you can bring him up. Oh, I think I went out.
He is there.
He is there. Yeah, I think you. I don't know what happened to my. Screens have disappeared. Not disappeared. Yeah, I think, but you are as a panelist, right?
Yes.
Yeah. So, if there are any questions, Neha, we have 23 minutes now. If there are any questions, you can just read out and we can, answer those things.
Sure, sir.
Good. So before the questions, maybe maybe 5 to 10 minutes. Can you give, some perspectives on it, especially student projects, when they build the hardware, when they build software, and with respect to the testing and all those things. Can you give some guidelines to this audience, who are listening to us?
Absolutely. See, first of all, the couple of points already brought in the presentation. Majority of the projects, if you look at, students are just stopping at, publishing some research papers, and they are not, really looking to take that into the market, right? So, and there it starts. So, if the products, the students, they want to become real entrepreneurs and, want to get into a startup ecosystem and want to take the product to market, then what do you call there are a lot of challenges which students are particularly not aware about. Specifically, related to manufacturing as well as compliance part. How to bring in the aspects of manufacturing, because students may be knowing maybe 50% or 60% about the design aspects and to make a functional prototype. And that functional prototype, once it goes into the market, and start behaving in the real scenario, the failures will start. Today, if you look at even big companies are recalling products, even though they have sufficient expertise in a lot of aspects of both the design as well as manufacturing. So that's the kind of how to bring into the academia and making part of the students' awareness can only be done with student or academia and industry partnership, I think. So that is so, generally I should say that that awareness of manufacturability related to how to scale manufacturing, how to improve the yields in manufacturing, what all, for example, if you look at specifically hardware products, the protection mechanism need to be built into a product to work in a real environment. It will be absolutely missing when you look at a prototype coming out of college. So, this is because students lack that kind of, knowledge of, that what kind of protection schemes need to be brought in. And also certain times if, specifically if the products are for healthcare segment, then how to take care of, compliance right at the design stage itself. Because it depends on what category of these products are going to fall in, what kind of patient safety or critical performances as a minimum, as a standard need to be brought into the product. Most of the time these kind of elements are missing. So definitely, my recommendation is that there has to be an academia industry partnership when it comes to products that need to be taken to manufacturing and taken into the field.
Yeah. I think maybe can you work so that yeah. So one of the issue, I am seeing all the projects, which was what you call discussed in the last 2 days, as part of the 70 projects awarded by IEEE. Students many times started from solutions because they have not gone to the problem and try to understand the problem. Because whenever I ask a question, have you connected with the community? What the students are saying, we have gone through literature survey. I told how did you do the literature survey? They told I went through the internet and things like that. I told them in the internet there are a lot of what you call false facts. So if you start leveraging the internet for everything, then you will end in disaster. So one of the important gap I am saying is students should start interacting with the community. For example, there was a very interesting project yesterday. The project was basically to go and rescue a child which has fallen in a borewell. So this with the 5,000 rupees fund, they have made a prototype. They award a 4-inch diameter transparent one pipe report, and they brought some DC motors and other things. And they demonstrated they have a camera which they will lower to the place where a child got trapped, and there is a light source there. And then a lot of interesting things they told, and they also attached some lever. So the professor who was in the review panel, she started asking, how do you ensure that these levers will be able to bring that child safely to the surface. So then she started explaining this can be done like this. And when more and more questions started asking, she started failing. So one of the input I was trying to tell her was, whenever you do projects, don't think of solving everything, because this is not a very simple problem. Okay, because it's a human being. It is not like an object which you can damage and then put it back. If you damage a human child, then what is the use of all these things? So in this case, instead of doing a whole solution with all the levers and all those things, if she would have at least ensured that a child is given some at least oxygen, because that place, there won't be, proper oxygen. So if you can inject oxygen, and if you can illuminate the child, and if you can buy a camera, get a feed of the condition of the child at this point, that functionality is more than sufficient for our project. But how to pull out a child from a borewell, that's a very, very complicated problem. And in fact, I asked, have you read newspaper articles where many children were saved like this? Then they told, yes, read that, but then I don't think they have understood the complexity of saving a child. Because even with the best firefighters, they have drilled holes horizontally, and then they reach the site. A lot of things. It's a very complicated field. But at least if the particular project she did can clearly tell this is the depth in which the child is trapped, and this is the condition of the child at this point, and then just doing some oxygenation there, and some spraying of some water if the child needs to be this thing. So these are small things students can do. So what is happening, in all these student projects, students are directly, getting into the solution, because most of the project they will say Arduino controls something, GPRS modem controls something. So that is all secondary. Solution comes secondary. So in my human-centered design thing, I will say, as Einstein told, 95% in a project or this thing, is for problem, identification, and 5% only, time people spend on, solutions. The real, people, especially, I've seen the projects now coming up from MIT, Stanford, various competitions. So there, students will tell, they've done extensive, survey, field work, basically to understand the problem. As I told, during empathizing, you will get a lot of, insights, and to prioritize the insights. Note that, in this case of these borewell stuff, all the insights she is trying to implement, as part of the project. But we need to prioritize, what insights, will make the best impact. Okay, so that's the problem definition. So once problem definition is there, you have to think about multiple solution alternatives, and then pick up the best solution. That should be the way, project should be done. So 95%, in identifying the problem, and 5% in the solution. So when it comes to solution, there are a lot of standard building blocks. That's the next question, which I wanted to ask Balamuruali. What do you think? In most of these projects, there are standard building blocks which are available, right? So how do you go about selecting standard building blocks for such embedded projects and things like that? That's a question to Balamuruali.
Right. So, talking about the standard building blocks today, the two very prominent building block, any student project quickly pick up is one is Arduino, and the other one is the Raspberry Pi. And we know as an industrialist, these products are not reliable enough. They will not have proper compliance. So that's the place it can get started, all problems. So, but these are the platforms students should definitely use for prototyping. There's no doubt about it, because accessibility and affordability of these platforms are always there. So they need to pick up that and learn things around that. But when it comes to that serious product, that is the place where again and again what we are repeating, that there has to be industry association, academia alone trying to do something, and then taking another round trip for looking at how to make a scalable and manufacturable product. You need to do a lot of reinventing the wheel, going back into selecting the right components, components meeting the cost, availability, factors, and then again meeting all these components. So today, the fact is that students, as you rightly said, that they start thinking about the solution and just get into internet and pick up what is available, from online stores. But these are not the real hardware pieces that need to go into product 95% of the time. So that the only answer for that is that students has to have industry interaction, and any serious product can be brought to market only that way.
Yeah. And one of the other thing is in the various project interactions. There was a project interestingly yesterday, where there is a glove-based, some sign language. One project was there. So that the student has implemented the project based on a low complexity, microcontroller board, And then during the conversation, he started telling, I will change it to, Raspberry Pi, that because it is a very powerful, microcomputer. Then I started asking, first of all, did you think about, what is the power, computing power that is required for your application? And I will try to understand what is the computing power of a Raspberry Pi. And one is computing power. Second is Raspberry Pi, from a 5 volt, it will draw almost 2 to 2.5 amps of current. So that means almost 10 watts of, power, that platform is going to consume. And plus, all the sensors, actuators, everything together, will go to some 15 watts or something. So I asked, how much power is available, for your application? Because you cannot put, a big, battery, there and then, because it is a glove, and then, you cannot load it with, a half a kg, battery, for making a Raspberry Pi work. So instead of, just start searching for, something which is faster, something which is very, what you call, a lot of features, you should understand what is the resources, what are the resources with respect to computing power that you need, what is the type of sensing that you should need, because finally these products need to be, what you call viable, because there is something called business viability. In the business viable, the cost is a very important factor, and there is a technical viability, feasibility is also there. So in design thinking, we say one is human desirability, that is one circle. The other circle is technical feasibility, and the third is business viability. So we need to make affordable products, especially in developing countries like us. So we cannot afford to start using some what you call costly components, and not costly component means these are the challenges. We have to think about lot of aspects, like one is power. So Balimalli, can you tell what are all other design considerations that the students should do when they build these projects?
Right. So, again, we're just definitely falling into the component selection, right? So one side, we can't blame students because, they also have the issues of and the challenges of, how to get it and where to get it all the time. So, see, for example, anything when we look at from an industry point of view, one aspect that definitely come into product design is, how to meet some cost target, right? And for meeting the cost target, there are two ways of selecting a component. Select a component that need a lot of work going upfront, or select a component which has got most of the things built in, but the problem is that that will be extremely costly and may not get that easily in a kind of small volume to start doing prototyping. So I don't have a very clear answer, because the reason is that these are the gaps definitely we see. Also what I want to say that again only the industry association only can fill the gap here, giving student access to the right components and what they need to select, because they should not do an internet search and select most of the time. And
that's a great perspective. And I also want to bring, one of the issues, you highlighted, a couple of months back, where a student team, was trying to build, a thermal sensor for, sensing, the temperature in the COVID scenario. So what was happening was, I was talking to the student team and I was asking, how much the sensor was costing. Then that person was telling us 600 to 700, rupees. Okay, and then I was talking to Balamurli about whether the solution that the student is doing, it's okay. Then he was saying, a typical medical grade, a thermal sensor is costing around 1,200 rupees. So Balamurli, can you tell where that student is going wrong? Can you just briefly elaborate on that?
See, this is again falling into the component selection. You need to definitely make sure that why there is a category of medical approved components, right from the supplier, is because the medical industry is highly regulated. So what happens is that traceability at the manufacturing place is very critical for any component manufacturer. You take it an FDA chase or what you call European Union MDR chase, whenever there is a customer complaint happens for any product, they jump into the product manufacturer. They look at all the components they use. Then if there is any defect in one of the components, these agencies can go and get into that component manufacturer. So typically what happens is that because of the kind of additional efforts in terms of maintaining quality system need to be there. Always the medical grade components are costly, and they don't manufacture in a high volume like industrial segment. So that is one of the reasons why medical grade components are costly, and then sometimes these components are costly because of specifications are totally different from industrial grade. For example, an industrial grade temperature sensor, for example, its linearity requirement and accuracy requirement will be totally different from a medical grade device. But apart from this, see, if you look at these components, these components which is costing 1,000+ rupees, the advantage for a student is that if they pick up, they can start reading the data directly out of the device. Yes, this solution also can be achieved using a 200 rupee sensor, but you need to have additional circuitry to do signal conditioning, and probably you may have to bring in a little powerful controller to do a lot of signal processing, noise reduction, and things like that, right? So one of the reasons why medical grade devices are costly is the reasons I said, but you can make trade-offs and take a decision of going for a low cost sensor, but bringing in additional circuitry to compensate that. But it naturally takes more time,
Yeah, and one interesting thing. Can you mute? Can you mute? Yeah, one of the interesting thing, what I have always seen is in the academia, nobody refers data sheet, components. Because the industry, that's a standard norm. Anything I design, I pick up data sheet and I look at, the extreme ranges, temperature where it works, and the voltage, for example, it's an input signal. What are the input, ranges? What are the output ranges? Then, all the different, specifications in the data sheet. But many a time when I interact with student projects, they have not even read their data sheet. Because what differentiates here from a layman? Today, if you look at evening, at 6 to 7, we are going to have, Niti Aayog's Ramanan going to be in the call. So his group has set up almost 10,000 tinkering labs across the schools in the country. So many of the projects that students in the engineering do, it is being done at the school level now. So, but then at the school level when you do, it will be like an amateur project, okay? Because they are not studying everything, what like an engineer does. But what differentiates an engineer is the type of rigor he is going to bring on this project. So one of the rigor I am basically, again and again seeing the gap is nobody is referring the data sheet. Unless you refer data sheets, you will not understand complication. Because putting components together will not make a good effect. You need to understand, whether this stage matches the other, there are fan in, fan out, and there are a lot of things in the electronic domain, because unless you take care of all these things, what will happen is your product may work in the lab, but then if you come on a Sunday, and if you wait, it will not work. So this is the type of rigor. Now, what I mean, like MIT, Stanford, and all, because many of the students who participate in global competition, they are already trained by faculty, to start reading data books and start looking at the problem. Because design is not a very simple thing. Design is not fancy. Design is not a color or the size of the box or the shape of the box. Design is all to do with how every minute detail in your circuitry you are thought through. Not only circuitry. Circuitry is with respect to the hardware domain, but when it comes to software design, even software design, unless you do it with care, this factor of software variability will kick in. And another very interesting point I want to tell you all, because when ventilators, calls came out in the last 4 months back by government and universities, many people started designing, ventilators. Within 3-4 days, they made ventilators. And I saw a lot of designs done like, cycle pump. And students, forgot that human leg is different from an electrical tire. Because they took, the gravity of the situation just like a cycle tire. So many people now purchase some, automated, what you call cycle pump, which has got a motor inside. and then through a relay, they will turn on the supply to that, cycle tire pump, and then we are showing a balloon where it will be, getting inflated and deflated. And then it made big noises. I saw newspapers like Times of India, Hindu, and all. Many students, started an bag-based, ventilator. But then I saw they use cycle pump. So that's where the sensitivity is coming up. So what is happening is there is something called failure mode effect analysis. That is something which we need to use in all these projects. When something fails, how it will impact the functionality of that particular product. So maybe you can touch upon that. That will be the last because we have got 2 more minutes. Could you just give some perspectives on FMEA? Yeah.
Right, but again, I have my own kind of interpreting FMEA from a student's perspective. Unless otherwise, they are having some amount of industry experience, because even fresh students coming to industry also, unless otherwise they go through maybe about a year of people putting their hands on projects and understanding what's kind of failure mode, and even companies also depend heavily on product recalls and install based problems to understand various failure modes in the device, because upfront kind of failure modes, because to do an FMEA problem, in a 100% justification, you need to know that all kind of possible failures right upfront. And once you know those possible failures, yes, you can start putting what is the likelihood of occurrence of this particular failure, and then come out with a measurable number along with that, and say that yes, this particular failure is very likely to happen and very likely to damage the device or its functionality, and so we need to have some remedial action taken in the design itself. So ultimately, it's for the design improvement. But FMEA being a last topic, I'm not sure how to put it up in this kind of forum as 1 minute.
FMEA in a full mode, that is not what I meant, because today there are a lot of YouTube videos. Even in a ventilator, there will be some 10 parts. So students should always think, this part fails, what happens? This part fails, what happens? And then, can some redundancy be built in? Basically, in the microcontroller board, suppose microcontroller board fails, the person will be dead. But then, if you have an alternate, microcontroller board, which will take over, in the case of the main microcontroller failure, like that, they can start practicing. Because what I understood, is the difference between the Indian universities and abroad. There, a lot of rigor is given on, this sort of design consideration. And they also do a lot of training on regulatory aspects, because a postgraduate student from one of the universities like Logitech, when I talk, he has understood everything, that is typical of an industry. But when we talk to IIT Delhi, their postgraduate program, I saw, it was that theoretical knowledge that they gained. So there is a clear difference between universities across the world. So today, from 6 to 7, Professor Ramesh is going to be there. He is the IEEE leader, global leader, 2021 elect. So he is going to touch upon some of these projects, and then even Ramanan is going to talk. And Professor Jamadakti is joining, today, because Jamadakti was the head of the system engineering lab in IISc. So he is a very good teacher, and so all of us are going to be deliberating from 6 to 7. So I request all of the participants here to join that session also. So I would like to thank Balamurli for spending time with us, and it was wonderful, and thank you very much. So over to Neha.
Yeah.
Sir,
I think we have to have the session. Yeah. No questions, I think.
Yeah,
Correct?
no questions. No questions.
Yeah. So I think, you can do the final listing, and then you can switch over to the next thing. I think we are 2 minutes past. So I think, Puneet is there. Okay.
Yeah. Thank you very much, Krishnan sir, for your wonderful session. First of all, on the funding opportunity, as well as what IEEE looks into the projects. And then after that, you have shown us several examples, as well as where people lack in projecting those things. And with the help of I think he has already left.
Yeah, maybe you've been busy with some work. I pulled some 30 minutes time.
Yeah. So very wonderfully, he has summed up all the questions what you have asked, what industry is looking for. So actually, in the beginning of this project itself, what we have done, we have also assigned one industry mentor. Your observations are really good that these projects are really good in academia perspective, but when it comes for implementation as well as when it comes for industry readiness, or we can say that going to the market, they lack that kind of perspective as well as insights. So we were anticipating the same. So that's why in the beginning of the project itself, I asked all the project persons that you should have one industry mentor also. From Bangalore section side also, we have allotted for 4 or 5 projects one industry mentor. But I think these students, they still restricted themselves with the faculty mentor rather than reaching out to the industry mentors. So that may be the prime reason why they could not get those perspectives. But your points are really good. And I think in the next year of next cycle, which will be happening in 2021, I think they all may be hearing now, they are going to implement all those things. And definitely we are going to have much better project than this year. But still I'm happy to see at least all 72 have completed their projects and they have really worked towards humanitarian technology.
Yeah. In fact, they are working for 5,000 rupees. No, the impact is very high because, for example, that borewell project itself, I saw a beautiful prototype, there. So with small money, when you give large money, then people become complacent. When small money, they will become more creative. So I think that way is great. So the same thing only hack also Karthik has done, $5,000 instead of $20,000, $60,000. So when you work within $5,000, people will do projects better than even $60,000 project. Because I compared 2 projects, what they did with 60,000, what they did with 5,000. I saw 5,000 is having more innovation component. So that's the beauty.
Yeah. Thank you very much. And I hope again you will be there back at the session. In the meantime, I will go with our first speaker of the evening plenary, I can say now, before last plenary. So we are already having Dr. Supavadi. I will just project her details and then we can.
Good evening, Supavadi. In fact, along with Supavadi, we did human-centered design, session.
Yeah.
So. Okay.
Yeah, and you have given, although I did not join, but I saw the topic. So you already given very good session on the HAC and then the project practice. Yeah, very good. Appreciate your contribution as always. Can you hear me?
Yeah. Yes. So I'll be listening in now. I go to mute.
So thank you, Dr. Supavadi, for joining us. And from last 2.5 days, we had several sessions on humanitarian activities, starting from plenary session by Karthik, and then moving towards sustainable smart villages. Then we went to the climate change and health and well-being. Today morning, we had 2 wonderful panel discussions on greener technology for greener planet as well as urban livelihood. Then we had this wonderful workshop. Now we are going to have your session. So just 1 second, slides are loading. We will introduce you and then you can take up. Okay. No issues. I will not wait for that. I will just read from background of this slides. So Dr. Supavadi received the BS degree in computer science from Maidol University, Bangkok, Thailand. She received the MS and PhD degrees from electrical engineering from University of Washington, USA in 1996 and 2001 respectively. She joined Choklingam University in June 2001. Currently, she is Associate Professor at the Department of Electrical Engineering. Most importantly, which I would like to describe about her, she is IEEE Region 10 Director-elect candidate. Hopefully, within 2-3 days, we will be having results with us. And she is, if you see from the IEEE HSE point of view, she is Chair Communications Committee in IEEE HSE, I think from last several years. So she is having very, very wonderful experience on the humanitarian activities. Now, with this small introduction, I would like to invite Dr. Supavadi for her perspective on COVID-19 related issues as well as funding opportunity from IEEE HSE. So, Supavadi, I am transferring the presentation rights to you. You can share your presentation.
Okay, so thank you very much, Puneet, for your kind introduction, and also thank you for the invitation for me to include in this important event of humanitarian technology organized by Bangalore Section. Yeah, and also thank you for the wish. I believe that all of our 4 candidates, we are waiting, next, I think should be Tuesday, Monday or Tuesday, to know who will be elected. Yeah, but thank you for all the best wishes. Yeah, so today I will give mainly the overview on the HAC and site effort on the COVID-19 response, and mainly as Puneet already mentioned, we have several highlight speakers that talk about several aspects of the HAC, include our chair, Kati. Yeah, so mainly I'm the HAC Communication Chair, and I'm from Chulalongkorn University, Bangkok, Thailand. And just briefly, that Chulalongkorn University is the first and established university, and it has been ranked #1 in Thailand. And of course, I have many role and experience in terms of the research, in terms of the advising a student, and then the teaching, and then also involved with the international organization. And mainly, like, I am devoted IEEE volunteer, and I'm in charge in these 2 years as the humanitarian activity communication chair. But other than that, I'm also involved with like new initiative committees and used to involve with ethics in IEEE. And also like a review for the IEEE Foundation. So all those give funding, and I believe that like Bangalore section and many other sections, of course, you have big contribution. In terms of the humanitarian technology. So I believe you have so many projects. Among these organizational unit of the IEEE. Yeah. So HAC mission, I believe like we already know that it is the mainly the wing of the IEEE that mainly as a volunteer we and then also on the technical strength that we have on the community, we would like to contribute our knowledge so that we could help to solve many of the community problems, and mainly how could we do that in the grassroots level. So that is like the origination of the humanitarian activity when IEEE Board of Directors decided to set up this committee, starting from the ad hoc, and then now it's like a full committee. And of course, as we see the previous strategic plan, it does say specifically that in the lead humanitarian effort is one of the strategic. But of course, for the new strategic plan, from this year until 2025. Also, of course, it does not specifically have the word humanitarian activity in there. But if you go through all of the 5, we could see that it all relates to what we can do for public, what we can think of like the new innovation, right? And also in terms of the education, as well. Yeah, so I believe that that could fit well that IEEE would still would like to push the effort in this area. Yeah, and as all of you know that HAC has the funding opportunity. Typically, like we keep project, we have the event support, we have the conference participation support, and also for side project as well. And of course, the funding has started like the beginning, like in the January call. But after that, because of the COVID, it has been in pause, in the suspend. And then, of course, later on, I will talk about the effort has been diverted to support the project, specifically with the COVID solution. Yeah, but of course now, if you see on the HAC web, they start to give the funding again. So please take a look at the HAC webpage and also on the Facebook, and then also for the site as well. So mainly as I mentioned, yeah. So HAC and site, of course, because we have original platform for the project that span over many areas of the humanitarian technology. But because of the COVID, so and I believe that that is very important in the world agenda, that IEEE should put the effort to help that. Yeah, so the COVID call proposal was started in April, and I believe it ends in June for the first call. And it does have many of the project submission like from around the world. And after that, it does open another call again, and it's already, I think it's the second round review already complete, and they have already granted the project. So that is the 2 round of the project. Yeah, and then like the cap of the project would be around like a $5,000 US. Yeah, so that is something like a HAC and site we originate the idea, to do that. Yeah. So as we see that the for the World Health Organization statistic, that the coronavirus disease dashboard, I believe I take it like from yesterday. And we all know that now it is like the world pandemic that now already over 36 million confirmed cases. Yeah. So, and then like 1 million die. Yeah. So, and then it's still like progressing, I believe, in many countries. Like I believe now India also what face the it's still increased, like Puneet, I believe it's still increasing. Yeah, so and of course India has so many population, and you have many projects that and then the government as well. So I do believe that we're gonna fight through that. Yeah, I mean, like for Thailand, it is fortunate that we do not have local transmission for several months, so the life is quite normal. But of course, we do have to be very careful and in terms of the government policy as well, that we still close the country. So that is like the situation that we could see the COVID. And then so when the HAC and SAIC originate the call, yeah, so the response is that there are 112 qualified proposals from 29 countries, and then from the 5 regions. And then you could see like the one with the dark blue color is India. So it means India has a lot of the submitted proposal, and then also a lot of the proposal has been granted. Yeah, so if we see in this page, so sorry, so we could see that the 73 proposal was funded at the $308,000 US. Yeah, and then something that sorry, I cannot see. Yeah, we can see like almost half is from region 10, and then from region 8, and then from region 9, and of course that not many projects from the US side. Yeah, and also we would like to thank that 2 projects also funded by the IEEE Foundation Donor Support Program. That's specifically for the COVID-19 response fund. And as we can see, like the highest number of the project was from India, and then we have some from region 8 like Uganda, Nigeria, and then also in region 10 Indonesia as is another country, right? And then also we have like Mexico and Colombia that has a higher number of the approved project. But we could see that it quite a span, I mean a lot in region 10 and then region 8. And then one thing that very important, like when we grant the project, because as we can see, like there could be many type of the project that could use to solve the COVID response, right? Whether, I mean, you build the medical device, whether you can use the technology of the ICT to help with some program and some of like signal processing and so on, or some of like the personal protective equipment or community sanitization, and also the device that could help control the infection. And another one is also in terms of the food security. And we could see that although like all of the equipment or solution that has been proposed, somehow it may be used in localized, the different in localized context. But anyway, the main technology would be pretty like a similar. Right? So it is very important that if we grant several of the projects, and then like we could bring out together and put it to theme like that. So it's been HAC and Psych, we have divided the project category into 5, right? And then so this would be the thematic area that we could group together. So this would help to increase like the project impact, the member engagement and professional development. So one thing that is like the idea, and that is already in practice, is the development of the community of practice, in which I believe that Jaya Krishnan, that he just shared the workshop. He is one of the COP. Yeah. So now there is a 5 COP, right? So when we have COP, it means the project similar nature would be grouped together. And then there would be some kind of the information sharing between that related project, right? Because if the project has been started somewhere and already has like the prototype, then it is very important that some other like a section or something could learn from the project that like already mature. So they don't need to start from zero, right? So the speed of learning curve would be increased. And also like when the experts come together, right, it is very important that they could give a guidance and mentor to make the volunteer in other section. And then also it could help develop and track the common indicator, what would be like a successful practice, right, and what would be measured, right? So all of this successful solution. Okay, and then one of the most important thing is like the lesson learned. Right? Because mainly if there is already the prototype here, so how could we replicate, how could we scale, and then how could we improve the efficiency in the future, right? So I believe that this is a very good idea, and of course it starts with the this COVID project response, but it will also apply to other kind of the project in HAC and SCI as well. So let's see an example of the medical device COP. So this could be the example like the low-cost ventilator and respirator, vital sign monitor. Okay, so somehow, these, as we could see, so they are like like majority is like in region 9, 7 project, and then region 10 and region 8. And if we could see by location, of course, we could see India as also the majority among, other countries, right? So, it is like very important that we could group this project. And then India could, of course, provide all of the successful example to the country like in region 8 and also in region 9. And the second is an infection control device. Right, so it is very important, like because it's an infectious disease, so it could help is some of the low-cost device for sanitation, isolation, and containment could be invented. Right, so it somehow it would be easy to replicate, and then also scaling to many kind of the area. Yeah, and here we could see again that region 10 has a 6 project on that, and then we have region 8 and region 9. And again, India have half of the infection control device invention. So when HAC and SCI given the project, right, and then of course after that we set up the community of the practice. And of course now we have the way that we would do the assessment of that project to see mainly what would be the impact, and then also we have to do the PR of those projects as well. Yeah, so they're gonna be something like each project they're gonna send we have some template for that, and then also some of the video of the finishing project as well. Yeah, so of
So
course.
Dr. Supavadi, we have to conclude.
Oh, okay.
Yeah.
I see. Yeah, I will. So, okay. So mainly there are some of the telehealth monitoring project of the Hyderabad section. Yeah. And then this is an example. And then also from the Kerala section, there are several projects like a portable mechanical ventilator, whole flow and non-contact measurement. Okay, and Indonesia section has something related to like the food security on the nutrition guide and recipe repository for family resilient in COVID-19. And also like example from the Sri Lanka section, okay, there is something of the code with women in engineering, let rise. So that meaning like it show off how of the several program would be showcased on the web page. Yeah. So of course, what you can do if you are interested, you can explore the list of the funded project, okay, which update regularly at the HAC webpage, okay. And then you also recommend some subject matter expert to be advisor of the community of practice to allow more engagement from the member. You could publicize your project relevant to your stakeholder, like video communication material, and then also identify potential opportunity for partnership additional funding. Yeah, so I would welcome everyone to visit HAC and site. And then also you could reach out to HAC project at atari.org if you have any interest and some kind that relate to this COVID-19 project. Yeah, so thank you very much for your kind attention.
Thank you, Dr. Supavadi, for a very wonderful presentation, and you have really brought out how HAC is helping in this pandemic situation of COVID-19. So I hope all our volunteers who are seeing this presentation, they will be really happy to see that what kind of support, and very nicely you have summed up by giving the project details also from the other sections. So I think after looking those things, they will be more encouraged, and they will be trying to replicate the same here again in Bangalore. And we look forward your continuous support, at least for now. We are going to have this every year affair. So hopefully you will be also supporting in coming years also this initiative of IEEE Bangalore section.
Okay, sure. I also heard that, I mean, the Bangalore section also have several projects as well.
Yes.
Okay.
Thank you very much.
Yeah. Okay.
So I think this was the thing. Now we will move to our next presentation. That is from Dr. Soma Pandey. She is from Reliance Jio. I will read out her bio. Welcome, Dr. Soma. Soma Pandey graduated from NIT Bhopal in CSE. She has more than 20 years of rich industrial experience. She has been mainly working in area of embedded systems and real-time systems. Presently, she is working at Reliance Jio in Infocom Limited on engineering the IoT sensors. She is having very illustrious career. I am not going to read. I will go to the end. Her doctoral research is in wireless mesh network. Her core area of interest are wireless LAN and PAN networks, IoT and sensor engineering, and IoT platform and LTE network. We are going to hear a very wonderful talk from her on how IoT can be useful for agriculture. So Dr. Soma Pandey, over to you. Sorry, I could not read your full bio because we are having paucity of time. So we want to listen you rather than going through this. Anyway, it is available on website. Over to you, Dr. Soma. I will give you the presenter's right.
Yes, thank you.
Yeah.
Thank you so much, Puneet ji, and it's a very proud moment for me to be having been given opportunity to present this talk about farming and the storage techniques. And thanks a lot. So I will.
You can share your presentation, madam.
Yes. So I will just quickly the correlation, because this is about humanitarian technologies, and I feel that there is a very important role of farmers in our life. I'll begin my presentation with a very common quote that all of us in India, before starting our food or meals, we always say Annadatta Sukhi Bhava, which means basically in English, we are blessing the farmers and we are telling them that may peace and happiness bestow upon one who provides us food. I think all of us before beginning our meals should do this because there is a spiritual connect also amongst ourselves. So we must begin. So with this, I begin my talk, and I just want to ask everybody. So what do we feel that is there a really? So I'm not able to move to the. Yeah. So now the situation, actually, the ground reality, if we see, 28 people dependent on farming, they die by suicide in India. And this is a situation despite, and then there is extreme poverty. So these are the challenges in farming. Like average Indian farm family can earn only about $3,000 in a year, and the entire family is working in the field. Besides, and this is leading to the mass exodus of literally every single day, 1 lakh people are moving to the urban cities, which is about a whopping 3.6% of the population. And if we see that India's main occupation was agriculture, this was what we were taught in our schools. But is it still the main occupation? Because when we see the percentage contribution in our GDP, the services is the main contributor to our GDP, having a 54% share. Industry has the second spot of 31% share, and agriculture has only 16% share of the Indian GDP. Despite 53% people being employed there, the GDP contribution is 16%. So you can see the gap over here, that more than half of the population is farming, but the percentage in contribution in GDP is just hardly like 16% is a very low contribution according to that. So if you see, the second thing that I want to draw your attention to, see the contrasting newspaper headlines. These are the headlines of November 2019. And if you see, the first headline says that we are going to import onions on 25th November. And in 19th November, what do we see? 63% of onion buffer stock has rotten away. It rots away in 19th November, and on 25th November, we have to import the onions, which is a huge amount of cost on our global storage capacity, on our the amount of buffer that we have for our the money that we can be used by country for some other development purpose. So the second headline that I want to draw your attention, if you see that angry farmers throw tomatoes on road. This is a headline of 2nd December 2019. And in October 2019, the onion prices were going at 60 to 70 rupees kg. So if you see these headlines, you can immediately correlate that, oh yes, why this is happening? Because there is some gap between the supply-demand chain. So what is it? So I'll come to that in the coming slides. But before this, one more compare-contrast I want to do between the service sector and the farming sector. Now, service people, they get their salary. And salary is something which can be deposited in bank or can be invested in something and can be liquidated as and when required. For a farmer, it is not the salary. For a farmer, it is the agriculture produce. This agriculture produce, the farmer must be able to use in future, just like, and can be liquidated into money in future. So how do we have to work around that? So this talk is mainly focusing on this. Before that, I'll just tell you one more problem that the farmers have to go through. That is the mandi and the middleman issue. So the mandis all over country were established so that farmer gets a minimum selling price for his produce. But slowly, the control on farmer started beginning to be exerted through these mandis. So much so that the farmer was not allowed to sell his produce outside of the mandi which lies in his jurisdiction. And in fact, just up till now, until this year, until before the pandemic came, this condition continued to be like this for farmers. Only after introduction of the new farm law, now the farmer has been given this freedom that he can go and sell anywhere in the country to anyone in the country and at any price as long as he is giving above the minimum selling price. So this is a food chain, the supply chain for a mandi, and if you see over here, between the farmer right at the down to the consumer right on top, just see the number of middlemen which are involved. There is a local transporter, then local mandi officer, then local buyer, then transporter again, big mandi officer, wholesaler and retailer. Just imagine the amount of add-ons and the commissions and the various corruption which will be involved because of this long chain. And this is one scene on a typical auction in a mandi where the farmer has to just lay down his wheat, and supposing there is a rainfall, if you can see, this is a regular mandi scene, and supposing there is India is a tropical country, anytime rain can come, and just see the situation. The wheat can anytime get damaged, it can get rotten or wet. So how do we protect how do we give a solution which is a win-win situation for all? So there is three-pronged solution wherein you should empower the rural infrastructure. Lot and enough has been said and done, and in SITE and in other humanitarian approaches, things are happening. Technology is working towards building smart villages, where there was a full session in this conference. I'm so glad to see on dedicated to smart villages. Then farming skill developments are there. Then the last one is freedom from middlemen. So this is very important. Like after 73 years of independence, also the farmers were not free. They were not free from the middlemen of the mandis and the mafia and political and red tape bureaucracy which was prevalent around the mandis. Now, with this new law, what we can do, we can now, because farmer is able to sell directly to the consumer, a huge plethora of opportunities are opening up. And amongst those opportunities is one opportunity where a village can be adopted by a corporate or a big company, and which can provide a silo or a storage facility right inside the village itself. So this is where I am going to take your attention to now. So before that, I'll just list out first I gave you the challenges and problems of farmers through mandis and other middleman things. Next, I will tell you the current wastage scenario in the country. So I want to assure you that according to World Economic Forum, food production was never be a concern for India. Despite having we are one of the largest democracies, and we have the second largest populated country in the world. Still, we never ever had a problem of food. Even any person coming visiting, or even we are feeding to the cows, and we are very liberal and ensuring that everybody goes on full stomach, has proper meal. So that culture is there in India, but that was never a problem. So what was the problem? The problem is that despite producing, we are one of the world's largest agriculture producers, but we have a shortage of storage facilities. So we produced 270 metric ton of food in 2016-17, which is much higher than the annual requirement. Then we are world's second largest fruit and vegetable producer, but we wasted 25% of the fruit and vegetables. Then in 2010, we produced 68 million tons of fruits and 129 million metric tons of vegetables. And we were the second largest horticulture producer in the world. But 30% of fruit and vegetables were wasted. So in India wasted an estimated 1.94 lakh tons of food grain between 2005 and 2030. So what is the problem? India is short of 10 million tons of cold storage facility, due to which over 30% of agriculture produce goes waste every year. More than 20% of produce from field is lost to poor post-harvesting facilities. India stores 65 metric ton of food grain, most of which is in bags in conventional, open or covered godown. More than 10 million ton of food grains are stored in open warehouses and are prone to damage and vagaries of weather. 10% of food grain that India produces is eaten away by rodents. And last but not the least, The preservation of food, very important is it can be preserved through food processing. And you see the comparison that only 7% of food in India is processed, whereas as compared to UK or even developing countries like Philippines processes 45% of its agriculture produce. So this is one gap, and because of which there is a whopping we are in ranked 100 out of 119 countries in the global hunger index. So if we save all this wastage, we will be one of the most prosperous from the agriculture point of view and the agriculture produce point of view. I just wanted to tell one story. Those of you who would have traveled in train through Europe would have noticed these structures all through the countryside, like in the hinterlands. They will encounter so this concept of storage in silo has been very old and has been known in every single nook and corner in villages in Western countries. But this silo scene is not so much there in Indian countryside. When I traveled, this thing struck me immediately, that why we are not seeing these kind of silos in Indian countryside. And from there, my mind started working that it's not always important to give a very, very expensive like this kind of steel silo structure. We can always go for low-cost silos, like this is a brick silo, and even simple low-cost poly silos. And these silos why can't they be installed in the middle of or nearby provided to every small village? I remember one line very long time back. I had attended a speech by a talk by one of our very
Dr. Kumar, you have to conclude quickly.
Okay. So this is a global scenario, and so I will just come to the condition in India is that we have very less. We only one private operator is there who is providing silo storage, that is Adani Agri Logistic, and there is no other silo facility here. So why not go for a smart food grain and vegetable bank for farmers? So what can we do in it? We can provide a small low-cost silo at each of the village, and also that is for the food grains, and we can provide a cold storage facility in every village. So these cold storage facilities can be solar powered, and with this kind of structure, the farmer will be empowered and will be can store their grain or agriculture produce, and they can withdraw whenever, as and when they want, just like we store money in a bank. So we can provide a smart food grain and vegetable bank in every single village. And it is not a very expensive thing, but it will give a long-term empowerment to the farmers, unlike short-term gains like waiving of loans, etc. So this kind of bank can be supported by an architecture in which we have some cold storage sensors and which will be connecting through Bluetooth to an IoT gateway, and through the gateway we can have an agri cloud and a smart farmer app. And this entire architecture will empower the farmer, and at the same time will allow the farmer to store their agriculture produce in a silo and a cold storage facility. So I will also like to quote one of the very good papers which was presented in this conference, a paper ID 113, in which they have proposed a cold storage, and it was really good concept, and I was happy to see that young generation is coming forward and working in this kind of topics, and it is being encouraged in IEEE conferences. So finally, we have this, I will conclude my talk by thinking on this direction and trying to do research so that finally we can achieve the goal of United Nations top 2 sustainable development goals, which are no poverty and zero hunger, which can be overcome by starting to think in this direction and doing more and more in this direction. Thank you so much. I'll conclude my talk with this very famous line by Shastriji, Jai Jawan, Jai Kisan. So let us really and truly work honestly in this direction of Jai Jawan, Jai Kisan and empower the farmers truly in true sense. Thank you so much. Thank you.
Thank you very much, Dr. Soma, for your wonderful talk, and especially for the farmers, how technology can be used for the betterment of farmers. And you have really touched all the important aspects of villages as well as farmers community. So I really appreciate and thank you for joining us and providing your wonderful perspective. Now I have paucity of time, but still I would like to take one question which has come from Yogesh. He is asking, over the years there has been many promises to farmer to better storage facilities, easy access to local markets, 24/7 electricity, water, healthy seeds, access to subsidy farm equipment, etc. However, with the new bill, these promises have been repackaged and farmers will yet not have access to better farm equipment, water, electricity. Unless he guarantees his produce to big corporates, what guarantees that the farmer's problem is solved with the new farm bill? So they are asking about the new farm bill which has come. So how it is going to be helpful?
Yeah, so the new farm bill, as I mentioned in my talk, it will empower the farmer in this way that up till now I showed the entire food supply chain and the middlemen and the mandi officers, their commission and everything involved. A farmer has to get up as early as 4 a.m. so that he reaches mandi in time and he can reserve his spot and he can keep his produce. That is his condition. Now he doesn't have to run around mandi. The buyer will go to the farmer in villages because now it is open market and anybody can go to any village and buy. So now they can just put as an auction. There is a e-NAM portal also from the government where they can put up their produce, and even in this pandemic situation they don't even have to go to the mandi, because I remember on the first day there was a talk in which there was a question that can we can afford to work from home, but can a farmer afford to work from home? So here this is one very good solution where farmer can go to the government e-NAM portal, advertise his produce, and the buyer will go straight to the village, get it picked up from there. Like, the future retail is there, Big Bazaar and all. They can just go over there, pick up the produce, and they can bring it to their malls. So lot of hassles for the farmer has gone away by this.
Once again, because we are doing a virtual conference, so we are going to acknowledge your contribution in a token of appreciation virtually. So please accept, and physical thing will be reaching you soon. Thank you very much.
Thanks a lot.
So now we will go to the next speaker. She is Dr. Harini Nagendra from Azim Premji University. I hope she has joined. So I will read out her brief bio. Harini Nagendra is a professor of sustainability at Azim Premji University, where she leads the Center for Climate Change and Sustainability. She has conducted research for over 25 years on India's forests and cities. In addition to over 150 research publications, she writes to a monthly Sunday column in the Deccan Herald, The Green Goblin. She is a well-known public speaker and writer. Her books include Nature in the City, Bangalore in the Past, Present and Future, which was published by Oxford University Press in 2016, and Cities and Canopies, the Tree Book of Indian Cities, Penguin in 2019. So we are really honored to have Dr. Harini Nagendra with us. Over to you.
Thank you so much.
I will give you the presenter's right.
Sure.
So you can share your presentation now.
Yes. You can see it?
Not yet.
Not yet? Okay, just a second.
We can see your cursor, but presentation is not visible. I think something else has opened.
Okay, just give me 1 second.
Yeah.
Yes. Now you can see it?
Yes.
Excellent. Okay. Yes. So thank you so much for this invitation, and it's a pleasure to be here and to speak to you all. I'm going to talk about, I think we don't have too much time, so let me jump straight into it. Thinking ecologically about Indian cities. And this might be a bit of something that, what we call an oxymoron, right? Why would you think ecologically about a city? In part because we are a country that is fast changing towards urbanization. In fact, we're a world that is rapidly moving towards urbanization. So if you look at by 2050, these are UN world estimates. By 2050, we're going to be a world that is more than 75% urban. And if you look at the reds and the yellows, India, China, Africa, Latin America, these are the places which have the fastest growing cities. So the urbanization of the future, where you have the more of the fastest growing cities, is very different from the urbanization of the past. Not like countries like the US or Europe, which is what we think of when we think of cities. Look at India itself. In 4 years, 2012, this is a night light satellite image. And why night lights? Because night lights are a very good proxy for urbanization of the cities, because only people in cities put their lights on at night. So 2012, look at this image. 2016, you will see already huge amount of increase in night light. I'll go back to 2012 again, and then back to 2016. So much urbanization in 4 years. We are yet to get the 2020 data for this. But even if you look at this, if you look at it in 2020, you will see definitely far more parts of the country. So India is growing at a rapid scale. We have 3 of the world's 10 largest cities. No surprise, Mumbai, Delhi, Kolkata. But we also have 3 of the world's fastest growing cities. So we are a very unique country with very fast growing cities. And this has a huge problem from the sustainability point of view. As we can see, there are challenges. These are pictures from all our cities, waste and frothing rivers and lakes, and we see this across the country. Urban heat island effects, where cities become 8 to 10 degrees hotter because of concrete heat islands. A paradox where you see the same cities, and sometimes their coastal cities, have floods and drought. So you have floods in the rainy season, and the same city is water scarce in the summer, and which is typical of Mumbai and Chennai, for instance. And you have huge amounts of air pollution, as we know. Indian cities have overtaken now, and in the world they have the dubious distinction of being the world's most polluted cities. So we have a number of ecological challenges in our cities of sustainability. Not just that, cities cover barely 3-4% of our total Indian land area. But they cause a huge ecological footprint on land outside the city. So for instance, in the next 10 years or 15 years, 3 times the number of protected areas as were before will come within an hour drive of cities, which means that you will see increasing tensions between wildlife and human beings, which means already we are cutting into elephant corridors, tiger and lion movement, leopards coming into cities. So we are going to infringe on conservation and protected areas. The increasing urban demand for water and for electricity is already drying our rivers, Kaveri, Ganga, Yamuna. We talk about sharing between states. But if cities take all the water, what are farmers going to do? The third problem is that of rising electricity and infrastructure demand. India is fast moving towards solar energy for renewable energy transitions. But the fact is we need so much more because of the consumption demand of our growing cities that coal is also an expansion in India. And that means further pollution across the country. And this brings me to my final point. Cities export waste hugely. Like we import electricity and energy from faraway places and food, we export our waste across the country. There are waste dumps outside every large city which is polluting the village air and water and farmland around the cities. So cities might be a very small fraction of the land cover of India, but have a huge footprint. So in short, we cannot think of sustainability in cities without thinking of ecology. We cannot think of sustainability in rural areas if we don't think of how cities can be sustainable. Right? So cities we need to understand how to think ecologically about sustainability, both for urban and rural well-being in India. And this is essential for our sustainable future. Now the question is, where's the data? So we did a piece of research which was published in Nature Sustainability in 2018, where we looked at the top 1,000 cited urban sustainability papers in an entire decade. And essentially trying to think of where is the data that informs how we need to practice urban sustainability. All of it is coming from the US, Europe, and some countries like Japan and China. And China is in a peculiar context by itself, because papers on China drive the debate on how to work on Chinese cities. So that, leaving China aside, from the rest of the world, the 800 or so papers that come from urban sustainability in different parts of the world, there are only 10 papers from India. The other context that could apply to India may be the South African context, from which there are 7 papers, and other global South developing countries from which there are 27. So we have 0.5% of our information comes from countries like India, yet all our plans, whether they're smart city plans or however to do urban development, all of these urban sustainability ideas and scientific vision comes from countries that are not ours, contexts that are not ours. And yet we know that Indian cities depend on nature in so many ways. Like you see this man praying on trees. This is all from our research in the past 17, 18 years on Indian cities. In the heart of our cities, we have grazing, we have dhobies, we have slum children who play on these saris tied to tree branches. We have women who have amazing kitchen gardens in slums that maintain their nutritional diversity and pass on an ecological heritage of what herbs to use and plants to use. Like this man, there are many people who go for a walk in the city praying to a tree on the way. Right? So these kinds of cities and their dependence and their close relationship with nature is very little known. And in large part, this is because we really have no information from cities like India in terms of their ecology. And this is in part because of a large paradox. Ecologists don't look at cities because they would rather look at wild places or places of nature, which they don't consider to be cities. And there are a number of excellent books and pieces of research in Indian cities, but they treat them as if ecology does not exist in the city. So in the next part of my talk, I want to give you a snapshot of Bangalore, which is my city and a city that I've done research in now for more than 15 years. If you look at the conventional history of Bangalore, it will say that Kempegowda created this city in 1537 as a market town, and in the small maroon portion right at the heart where you see here. And he built it in this barren land where he came and he saw an auspicious site and decided to found a city. However, when you go back to old inscriptions, and inscriptions are a good way to look at ecological history of a landscape, you will find inscriptions on stones and on copper plates that help you understand the ecological history of this landscape pre-Kempegowda. They start from around the Ganga dynasty, the 6th to 9th century AD. And this is what we call a topographic map of Bangalore. So the black line is the boundaries of Bangalore municipality superimposed on a topographic grid. And what you can see is the west or the areas to the right are fairly flat, and they were what is called the Maidan of Bangalore, the fairly flat areas. The left side or the western side is much more rich and undulating and very sharp terrain. In this place is a thorny jungle which is full of wild beasts. In the eastern side or the Maidan side is what you have a relatively flat area where people can settle into agriculture. So you can clearly see that the ecology, the areas to the east, are where people first started moving in. Bangalore is a very unusual old civilization because it is distinct from any large water body. There's no large river, there is no coast, and yet we know that this area was settled at least 8,000 years ago. There are Paleolithic stone tombs across this landscape. Sorry. So what you understand from this is it was old and settled. Where did they get the water from? As these people came in, they exploited natural depressions, and you can see where these are located are at natural depressions where they scooped out the mud and built lakes or tanks, rainwater harvesting structures. Then the Chola dynasty comes in, and then from there on the Hoysala dynasty, which is they're big lake builders. So they build a number of rainwater harvesting structures, and a good example of this is serial number 1, Honga Sandra. Sandra, the end appellation, means Samudra, which means large body of water. So these were all lakes that they created, and a town grew around the lake. And finally, by the Vijayanagara dynasty, by the time Kempegowda comes in, there are 75 villages in this area, at least, that we have documented through these inscriptions. They have all built lakes, started growing rice because of that harvest, planted trees to improve the climate, and grown orchards. Right? So they're moving in, but they're improving the landscape as they move in. They don't degrade the landscape. They, in fact, improve it by creating more water bodies and planting more trees. And there's an example of an inscription. They say that they moved in, they created the tank, and then there was a wet and the dry land, that is the paddy and the millet. And they include, look at this imagination, the wells underground and the trees overground. None of us do this in surveys today, right? If you survey a piece of land for sale, who talks about the wells in the underground or the life-giving water underground? Who talks about the trees overground? First thing you do is you cut the trees, you drain the water if it's a marsh, you dig a bore well and mine out all the old water, and you construct a large apartment, right? Or if there's a stone boulder, you break the boulder by using explosives. But look at their impression of this land. So this is life-giving, and it includes the wells and the trees. So in this life-giving land came Kempegowda. His dynasty stayed for a few years, and then Shaji, the famous Shivaji's father, came and ruled Bangalore for a few years. And here's a poem by his quote, which describes Bangalore at his time. So it's in 1670, but it's describing Bangalore around the 1640s. Again, you can see it's a place of nature. Shadi comes, as Kempe Gowda did, and adds lakes and adds trees. So the city resounds with coos of pigeons and peafowl. It is teemed with deep lakes. There are fountains at the square, trees thick with flower and shade. The city is dotted with countless lakes, each as big as the sea. So the Samudra, that same idea comes back that I was talking about, the Sangras of the Hoysalas. There are picturesque parks festooned with creepers. It's a green city, and each successive ruler, like the people, adds lakes and adds trees. We can see this in the British times too. In 1791, when the British first took over Bangalore, after the Third Anglo-Mysore War, this is what Bangalore looked like. The lakes and the trees. You have clumps of trees which are orchards, trees along roads. Otherwise, it's a barren open landscape. This is a semi-dry Deccan landscape. And this is how it looks in paintings. But by the time of 1888, more people have come in, more lakes have come in, more trees have come in. So the British find that the place is too hot. Again, they plant trees because they want to make the climate better for people. Why I'm telling you this is, we need to break our common story. We say that when people come in, what can you do? It's a city, people come in, they degrade the environment. I think what we see here is for hundreds of years, people came in and improved the environment because they know they have to live here. They know they need trees, they know they need water bodies. So they actually improve the environment. It's only much later. So this is again the Bangalore that is beginning to have more trees. It's planting trees, and you can see these photos around this time. And by 2015, what happens? Most of the lakes have gone. Why? Because piped water comes into Bangalore at the end of the 19th century. Once piped water comes in, all the lakes go, all the open wells go. In fact, to the point people start throwing garbage in lakes and throwing corpses in wells. That's the extent to which, these were worshipped. There were goddesses in these lakes, and they were worshipped and kept clean. But the moment you got piped water, you don't recognize the importance. Trees still linger because it's still a hot city, but even trees have been cut down in the hundreds and thousands now, and for widespread expansion of roads and metro and flyovers and underpasses and railway lines. So we have lost our understanding even of the importance of roads. And if you look at our maps of the city, for instance, between 2000 and 2007, you'll see that there is in the heart of the city some green patches, but the green patches that are left in the heart of the city are only those colonial ones that survive in army compounds or something in an old school building, something that is protected. Anything in public areas which are not protected of this kind have all been set. And this is despite the fact that we know that biodiversity has a lot of value. Purely economic, if you're a company, you should plant trees because you can reduce cost of air conditioning. If you are a social kind of structure, you need to have green space for public space. If you're looking ecologically, I'll show you a simple experiment we did. We looked at trees along the same stretches of road. Okay, the same stretch of the road, the same day, with one stretch with trees and one stretch without trees. And we all know there are roads which have some places with trees and without trees. What do we find? Here's an air filter. We suck air for 8 hours through this filter. Without trees, this is how black it looks. This is how our lungs presumably look. And with trees, this is how, it's just lightened because the trees have taken most of the carbon away. Here's a better graph. It will show you the suspended particulate matter is reduced by 75%, which means it's much more within permissible limits. Sulfur dioxide levels reduce. Air temperature reduces by 3 to 5 degrees. And the surface of the air, of the road, the surface of the road tar decreases by 30 to 35 degrees just by having trees. Why is that important? Because once you get to 65, 70, 75 degrees, which we are going to get under climate change and urban heat islands, the tar starts melting. So you cannot even walk on these roads, and this we are finding in many parts of North India today because of climate change and heat waves. We can already not walk in these cities or use the roads. We need urgently trees on our roads. And what are we doing? We're cutting trees across the road. So what's the way forward? I'll quickly wrap up. I'll give you an example of one restored lake, Kaikondoli Lake on Vijayapur Road, and Bangalore is famous for its lake revival in recent years. Why? Because water tanker prices have gone up, the city is running out of water, and residents realize that they must come together to protect the lakes, because only when they protect their lakes will the groundwater levels go up. So here's a restored lake. In 2007, this is how it was, swampy, half dead. It was then restored and maintained through a collective collaboration between citizens and BBMP. And this is how the lake looks today. Over 100 species of birds. It's a thriving bird paradise in the heart of the city. And people come all over the city, and we have got fascinating stories through our research of people who now say that Bangalore is their own because they come to this lake. And that's why they fight to protect this lake. They could be migrant workers, village residents, transgender communities, special needs children, parents, grandparents. We thought everybody who comes to the lake feels now that this lake is part of the city. They feel it makes them feel familiar and they're willing to fight for the city. Right? So I'll conclude with this. It seems like in the specifics a story of one city, but Mumbai was built around its ecology. Delhi was built around the Yamuna River. Hyderabad was built around the Musi River. Chennai was built around its floodplains. Udaipur is a city of lakes. So across India, small cities, big cities, they're all ecologically unique. They're built around the foundation of nature, and they are now dying because we have forgotten that they're built around the foundation nature. So these are two books of mine. One is an ecological history of Bangalore, nature in the city from the past 1,500 years, and another Cities and Canopies with another colleague, where we are trying to talk about the changes in how do people relate to cities in India through various ways, through poems, through art, through science, of course, and through recipes, and through a number of other ways, because we feel like we need to understand and embed ourselves in our ecology. Otherwise, we can't be citizens of a city and look for urban well-being in any other way. With this, I'll end. I'm open for questions. And I hope we still have time.
Yes, thank you, Dr. Harini. Thank you very much for your wonderful talk. I think for the first time, people might have heard that because of human population also, landscape as well as greenery improves, and there will be an improvement on the environment itself. So that is very good information, and I fully agree with you. Yes, once people will come, if they want, they can really improve their nearby environment rather than only thinking about themselves. So thank you for those words and information. And floor is open for questions. I want to know if anyone is having any questions. Please type in the chat box or in the Q&A window. Or any panelists, if you want to ask any question, you can just unmute yourself and ask the question. In the meantime, I will see if any questions have come.
I wanted to ask one question. Can I ask?
Yes, please go.
Yeah, ma'am, this you know that city development plans are there, CTD, and in that, what is the regular trend is that slowly first a green space will be converted into a commercial space. So now, because already you are telling that Bangalore is already quite congested and we should not give up our green spaces more. So is there any provision that we can permanently like freeze the CDP and no change in the green area of Bangalore?
This is an important question, and see, technically you are not supposed to take ecologically sensitive spaces and freeze them as green spaces or valleys. In practice, we all know that with all cities this gets transferred, and it has happened in Bangalore also. For instance, there was a very important wetland down upstream of Belandur Lake, which is Bangalore's largest lake, which was going to go. There were apartments and there were big builders taking over. But because a number of lake groups in Bangalore came together and filed a PIL with the National Green Tribunal, because of that, this entire wetland was saved. Now, one wetland was saved, but many others have been destroyed because they also filed PILs, but those did not go through. So yes, in the plan it is frozen, but in practice, government manages to find ways to give approvals, and builders somehow find their ways around it.
Yeah, like we have been fighting for 20 years for a lung space in our colony, which has been converted slowly from a green area to a commercial. And it's been 12 years till we have to get justice. That's why I thought maybe we can have a good idea to freeze all the green areas at least of Bangalore permanently, no change in it like that.
They should be frozen, absolutely. But and we need more voices to say this.
Yes, ma'am. Yeah, I agree. Thank you, ma'am. Thank you.
You muted yourself, I think.
Okay. Yeah, thank you. Yeah, so I was just saying thank you very much. Okay, I again got one more question. So there is a question again. Recently, government announces new rules in environmental law wherein anyone can continue working on a project and later get approvals. Your thought on that?
Yes, this is going to be a difficult law for us, especially in cities, because there is an exemption. The new EIA rules have an exemption for road projects especially, and highway projects we know are very detrimental to green cover around cities. And there were provisions before for environment, for a consultation with citizens. Of course, even those were not followed, but the provision was there. So this is going to be challenging now for people to start protecting the trees. It may open the doors for more tree felling, but we have to see as we go along.
So I think I have to stop at this point of time because we are another speaker in the queue. So thank you very much for joining us, and hopefully next year again in BST's 2021 we will be having you again, when we will be most probably doing a physical event rather than a virtual event.
I'll be happy to.
So I will take your presenter's role, and we would like to give you electronically or virtually some kind of a memento. Just wait 1 second.
Thank you.
Thank you very much. So friends, now we are going to have another session from Himani Shah. She is co-founder of Intello Labs. I will just, I think we missed her bio here. So Dr. Himani Shah, can you just unmute yourself and switch on your video so that I can introduce you?
Sure. Yeah, are you able to see?
Yeah. Yes, thank you. So friends, Dr. Himani Shah is co-founder of Intello Lab, and she is working on mostly agriculture related activities, and she is going to provide her perspective on agriculture 4.0. I think the title of her talk itself is very, very exciting, and without taking much time of ours, I will directly hand over the mic to her so that we can hear us more, and then at the end again we will be coming back for the question and answer. So over to you, Himani. Thank you. I will make you a presenter.
Yep.
So you are presenter now.
Are you able to see?
Yes, we are able to see your slide. You can just do full screen and go ahead. Yeah.
Okay. I have done full screen.
Yes.
Okay. So thank you. To give a intro. I'm the founder and CFO at Intello Labs. It's really a pleasure and privilege to get this opportunity, and I want to thank you all for being here. Hope everyone is, safe and in sound health. Before we go through the history and journey of agriculture, let me quickly also introduce Intello Labs. We are a small agri-tech startup founded in 2016. Our vision is to bring transparency in the agriculture supply chain. And we have started with digitizing quality across fresh produce supply chain. And this actually has a lot of impact. I think Dr. Soma also talked a lot about horticulture and farm producers. And we believe that, in the entire supply chain, this has some role to play. And we'll touch upon that later. So I think, like we mentioned earlier, so fresh produce market, right? To give you an idea, it's around $1.5 trillion, right? And approximately 1/3 of that, which is $500 billion, gets wasted. This is like really massive. massive number globally. And this is just fresh produce, which is fruits and vegetables. When we look at total food loss, it's around 1.3 billion tons food, whose value is like $1 trillion. And these are public numbers. They're published in FAO website. So a little bit fun fact around this number is that area larger than China, which is like the largest country, is used to grow food that is never eaten. So this is really a huge problem. Like, this is just to give an idea of size of the problem. This loss is split into various stages from in the entire supply chain, farm to fork.
To the session. Yeah.
Sorry?
Himani, your now it's visible. Your slides are not visible.
Okay. Is it visible?
Yes, it is now.
Yes.
Go ahead.
I think it has paused or something.
You are presenter. You can just take away the presentation, again load it, so that may work. Yes. You can go to the presentation mode. Yes. It's visible now.
Okay, great. You're still able to see the presentation.
Oh, as soon as you go in presentation mode, it grays out. So there is some other issue.
Is it still graying out? Or?
Now it's good. No.
Okay. So,
again, it's great. Maybe you should share screen and don't share the app.
Okay. I think if you're able to, sort of see, I'll try to explain.
No, we are not seeing anything. So what I'm saying that share your screen. Don't share one of your app, just the presentation. Go back to share. But now it is visible.
Right. Anyway, so sorry about that. So anyway, let's look at what is agriculture 4.0.
Can you go back to where you were last? Last it was visible. Now it is not. Yeah, stay here. Now, yeah. Now this is fine.
Don't move your cursor. Just leave it there.
Yeah.
So technology around the world is changing rapidly, right? And agriculture industry is still sort of catching up. Over the last many years, we have had practices of agriculture 1 and 2.0. And now we are moving towards 3 and 4.0 in different parts of the world, practicing different incarnations of this technology. So agriculture 1.0 is mainly when farming was happening with a lot of manual labor and traditional ways in around 1920s. Then we got more machine fertilizer, hybrid seeds, which help increase the production with less manual effort. 3.0 involves technologies like specialized softwares, basic weather reports, and so on. And now there are actually automated farm equipments and a wide array of IoT sensors that measure everything right from soil moisture to even the drones, which keep track of crops. And this has completely changed the way agriculture business was being done, even in rural areas. So this is, we feel that today we are at the inception of Agri 4.0, and we know that this kind of digitization is far more efficient and sustainable than its counterparts in the past, right? So why do we really need agriculture 4.0? What is, why can't we maintain the status quo? So the human population is projected to reach around 10 billion by 2050. And there is the need of, finding better, smarter and environmental friendly ways to grow food and bring it to the end consumer. We have to significantly increase our productivity in terms of food generation and logistics related to it, right? Clearly, there is a lot to play for in Agri 4.0. Not only in terms of feeding the world more sustainability, but also in terms of business opportunities. And that's why we see a lot of businesses also cropping up in this area. Of course, there will be some unforeseen situation like the world is facing right now. But this has actually taught us, that we need to incept technologies that require minimal human interactions. And the technologies that are easy to adopt. This do not require a lot of effort to update itself, and can sort of adapt to market and situation needs. There is tremendous focus now from the government as well as private organizations to bring digitization in the entire supply chain and even the trading of agri-produce. I think we touched upon the farmers' bill as well, right, in the previous talk. So there is a lot happening, overall in the environment. And let's look at some of the examples of Agri 4.0 in achieving this, the purpose, right? It has variety of technology, and for this talk, I picked up basically 3 imaging technologies. One is the satellite, and these 3 technologies are used at various points in food cycles. Right? They have several use cases with health and overall supply chain. Satellite, drone, and mobile camera images, which is like farthest to the nearest, is what we'll sort of touch upon. Right. So this is a satellite image data application, and there are several companies globally working on these at various stages. This can be used for better understanding of fruit cultivation. This is a case study for pineapple, and hence the total expected production across. This involves collecting satellite images across area, be it a farm or a country or a world, applying computer vision and deep learning. Right, to first of all determine which areas have pineapple, and then we use technologies like NDVI, vegetation index analysis, and so on. And basically, all this data can be analyzed to arrive at reasonable estimate of country or the world's expected production. And combined with the ground data, it helps the grower to plan the production better and control their budget. This is another example where we are using drone images, right? And this is example of a palm plantation, which are usually grown in few thousand hectares of area. Different parts are typically in different stage of growth in the entire large area where the palm plantation happens. Some get damaged by elephant attacks, some need additional nutrients, and so on. So it is a complex task to locate what is happening where with feet on the ground. And accurate and early detection is necessary to take corrective action. And impact it has is in millions of dollars. Right? So using drones, data can be easily collected, and using AI and computer vision, again, we can get very useful data, which can identify, mature versus immature tree, and hence when to pick, what is the yield estimation, identifying unplanted or damaged area, which needs fresh plantation activity, and determining if there was any forest area which was cleared by comparing, images and so on. So a lot of useful data that can sort of be derived using drone analysis. So finally, the third one, let me talk about the application of mobile images, and this is what we are working on even at Intello Labs. Using a mobile application, anybody in the food business can take an image of fresh produce and get a digitally verifiable quality report. Our deep learning algorithms identify each of the contours as individual items, and then segregate, sort of between good and unhealthy items. This is a very objective, non-destructive, and scalable solution. It is applicable across food supply chains from farm to fork, anywhere in the world. And currently, this process is completely manual. And because of lack of any digital way to assess quality, there has been traditionally a lot of need historically to actually have a physical trade. This is a very key point in enabling, the trade online. Okay? There is around 21.6% loss of fresh produce in the retail supply chain. Right? We saw that there was overall 30% in the overall farm to fork. This is just the retail supply chain, and cost due to various reasons like wrong purchase, dumping of good produce, in storage and handling. There are several options. Right? So this quality tracking solution helps in reducing these losses at various touch points by aligning the quality checks to the right decision making. The lack of objective assessment of quality continues to be a bottleneck even in bringing transparency across the value chain. So we are working on F&D, and we've collated list of produce and quality parameters, made it more objective. So we seek to not sort of just bring fairness in the fresh produce trade, but also ability to bring in quality assurance with no physical involvement, like I mentioned. And this, as we discussed earlier, it assumes even greater importance in this post-COVID world, where we are looking at less and less human intervention and touch points. Consumers will become increasingly conscious, of food that they eat now, and the hygiene and the health factor of it. And this technology of mobile imaging, when integrated with entire blockchain solutions, and when it is democratized to give that power of checking quality to everyone, it becomes a very powerful solution for the entire world in agriculture 4.0. Okay. So I want to sort of conclude that it's still early days. I think overall there is a lot of technology evolution that is required in agriculture, and everyone has a part to play in reducing the food loss and waste. We aim to work with broader spectrum of stakeholders and partners to tackle the problem. But now is really the time for industry to adopt more digitized approach and implement the innovative solutions. As per a report by AgFunder, agri-tech startups have grown more than 80% since 2012. And we see that even big businesses are investing millions of dollars in technologies like precision farming, automation, data analytics, smart irrigation, and so on. Last year, the funding received was around $20 billion, right, just for agri-tech startups. So I'm really looking forward to see a lot of innovations happening across the world. And we see there is a huge rise of interest even in the investment sectors. So thank you. Hope this was helpful sorry about the technology issues. I hope you were able to see the present.
No problem. Thank you. Thank you very much. So you have really brought a new perspective of agriculture 4.0 where you are using satellite imagery as well as drones. So I just wanted to know how many places whether we have implemented anywhere and in any village particularly where before implementation and after implementation, what are the real outcomes you have, real changes you have seen?
Right. So we have, and interestingly, we actually started earlier, few years back, in some mandi, right? But we realized that, until it is top down, until, the buyer starts realizing the value of quality assessment, directly approaching farmer was not really helpful to the farmers because the buyers were still, set in their ways. And we started with retailers. And we saw a lot of traction and reduced wastage in terms of retailer supply chain. So instead of throwing away the produce after a certain number of days, they were actually able to plan better, evaluate what they are throwing away and what can still be sold. Instead of first in, first out, you can sell the right produce which is sell today. Put that in shelf display. And we also saw a lot of reduction in customer returns for the online deliveries of F&B that they do because you have checked the quality throughout the supply chain and even at the time of dispatch, which is like a huge because cost of customer acquisition is very high for retailers. So loss of customer leaving is a huge addition to their top line as well as and now we are sort of moving to aggregators as well. In fact, I think with COVID coming in, at least in this space, we have actually jumped 2 years in terms of changes, and people are more adaptable to having these technologies used for trading.
So what kind of challenges do you face when you go to the farmers as well as you are telling that you are going to the middle level people where you are trying to go through them rather than going to the farmers? So once you approach to them, what was the challenge you have faced? Means why they were not able to adapt your technologies when it is going to be helpful to them?
Right. So like I mentioned, unless the buyer accepts, right, that, this is a good solution. And if it says that, the quality is good, I'm willing to pay a better price. Or I accept this and, I am willing to bid basis a report and not actually have to, it is not useful for farmers to just say that this is the quality of my produce. It has to come from the buyers, not the sellers. So I think that was the reason when we approached like a mandi or a farmer, that it did not work very well because it had to come and the entire supply chain, the end consumer or retailers or a horeca segment, right? And when you sort of keep like go down the supply chain and reach out to the sellers.
I can see few questions are popping up. I will just read them for you.
Sure.
So they are appreciating your presentation and then they are asking, is Agri 4.0 you presented a globally accepted definition or was it a convenient way to showcase the technology adoption in Agri?
Sorry, I didn't get it. Global
No, they are asking whether Agriculture 4.0 which you are presenting is a globally accepted norm or you are just showcasing your technology for your convenience.
No. So I'm not showcasing our technology. Definitely, it is. So it's hard to say. I think there are a lot of speakers and research, around agriculture, 1.0, 2.0, and so on. 4.0 is not, I would say, completely established that this is the era, but I think that there is there is a huge revolution where we feel that it's an inception of that 4.0, and a lot of speakers and researchers are talking about it. And not coined by me, the term.
Okay. So thank you very much, Himani, for your wonderful presentations, and we are really happy to see that the startups in India, they are working towards technology which are going to help farmers, in a big way. So thank you very much. And this being a virtual conference, we are trying to virtually give a token of appreciation. So please wait with us for 1 more minute, and we will share you electronic token of appreciation. And definitely physical one will reach you soon.
Thank you so much.
Okay. Thank you very much. So friends, with this we have completed this plenary from 3 to 5. Now we are going to have 1 hour of break, and after that 6 o'clock again we will be having our last plenary, the valedictory session. In that we will be having again 4 very distinguished panelists who are going to talk about education, entrepreneurship as well as policy. So do stay with us and join us back again at 6 o'clock. Thank you very much. And I would like to thank again all the panelists as well as Dr. Sadhana, because she only have asked all of you to be here. So thank you very much.